Good morning, everyone. We're back. And as usual, unfortunately, I cannot say we're back to all of the people on our list. We're going to have to figure out a better way of introducing the space every time. This is the nature of the Twitter beast. It sucks. Anyway, today we've got a lot broader show than I originally thought we were going to have. Well, when we came up with the this category about 10 days ago. And it was interceded because there were other things we wanted to do and needed to do. This was essentially going to be pretty much a one shot plus extra information, as we always do. We never stick to the main thread. We're always broadening out and expanding into other avenues. And as the week went by, more stuff came out, and then more stuff came out, and Hansen came out, and uh, the uh, the tariff tribulations came out. So we ended up having what I think is a very exciting, very interesting set of discussion topics today. And we're going to go through as much of them as we can in as much detail as we can. Um, and then I forgot exactly when, but it was like late afternoon on Tuesday, all of a sudden, and I check this every single day, but NASA had released not just 1 but 2 months worth of series data. Series is their uh, satellite-based information on solar versus atmospheric, long wave, short wave, uh, light emissions. So it examines how much light is coming in, how much IR is going out, how much visible light is being refracted uh, by the clouds, reflected by the clouds, reflected by ice. It's this thousands of parameters that they uh, carefully examine to see what's going on in the energy balance of the sun, earth, clouds, atmosphere, lithosphere, uh, that's the land, cryosphere, which is the ice, water, all of these tons of parameters are done in very high definition. I think it's like some of these things are released every 5 minutes, some of them are released every hour, but I only look at the monthly because it's already ungodly amounts of data. And what we see is that albedo is starting to make its way back to where it was a few months earlier, which means that the Earth is becoming a little bit more reflective and more energy is being bounced, light energy is being bounced away rather than being absorbed. Might as well add that the last few days, the sun has been a little bit, quote unquote, hotter. We have, well, we have more than two, but we have two basic solar measurements. We have insolation and we have sunspots, which is really it's tricky. Yes, insolation and sunspots are related, but they're not very, very strongly related. So when you hear people say that based on the sunspot data, you know exactly how much energy the sun is given off. This is not, it's got an R squared of about 0.56. So it tells us what's going on, but it doesn't tell us everything that's going on. And there is also other frequencies of light that we can use to see how the sun is doing. I'm stretching this. Sorry. But yeah, we have all of this information that is coming in the last week. And then I wanted to do a rant, and I'm waiting to have a few more people to come in before I do the rant. But I guess we want to get a lot of stuff together today. So I'm going to begin with the rant first. Oh, by the way, Hi, everybody. If anybody wants to wants to have be a part of the conversation, just raise your hand. We're very friendly here. I don't think we've ever. Kim has joined us. I don't think we've ever blocked anyone or prevented anyone from speaking. We've been we're very easygoing here. We even take criticism very well. Uh, at least under my breath, I take it very well. Okay, so here's the rant. Most companies, most businesses, most people, they want to know what's going on in the future before they make their decisions on how they're going to allocate resources in investment. So you want to know when you're building something, how much it's going to cost you today, how much it's going to cost you tomorrow, how much it's going to cost you in 6 months, so you know how to charge your customers because you want to make profit. The whole idea behind doing business is to maximize profit. I know that that might hurt people's feelings, but yeah, we want to know if I'm building something, which I did for years, I want to know how much to charge my customers so I can make as much money as possible, so I can pay my people as much as possible, so I can broaden my market share, so I can stretch out to new avenues, et cetera, et cetera, et cetera. The first thing they teach new engineers who are on their first project is get as many sources as possible. Because the one thing you do not want to ever happen is you have an assembly line with 86 people on it, and all of a sudden, one part is short. So you have to stop the assembly line at that one part, and then you have to warehouse everything. You have to take everything off the assembly line. Yeah, what you can do is you can stock extra assemblies, and then later on, when the time comes, you can go back to from where you left off, and then you can, once you get that missing part, you can keep going. But that takes a lot of time, takes a lot of effort, and then you always have to ask yourself, okay, did we do a full QC check on each and every single one of these? So it's murder. You never want to stop an assembly line because one part is missing. And by the way, this is also an important part of biology, which we'll talk about later. So you never want to have one part short. You never want to have anything short. You want to be able to go from start to finish. When your supply chain is interrupted by tariffs, this is the worst thing imaginable. So what you're going to do if you know that tariffs are going to rise, and by the way, I would suggest people check out the United States GDP fourth quarter to look at how imports rose in the fourth quarter compared to exports. The reason why we were importing so much more in the fourth quarter is because a lot of companies said, oh my God, Trump is going to destroy our import capabilities, so let's buy extra parts. So when you suddenly you get tariffs, you don't know down the line what's happening. I'm buying a part custom made for me from this company in Mexico or Canada or China. And it happened to me so many times. And suddenly they come up to me and say, we got problems. We can't, we're shut down the assembly line for a couple of days because something went wrong, or the mold failed, or the plastic was having problems. And you are screwed. If that part is unique to that assembly, that no one else makes it in the world, and this happens all the time, you are you are shut down. So this is why when companies build products, they can't just say, well, let's find a new vendor overnight, because now you have to qualify that part. For most companies in the United States or Canada or Mexico or the European Union, there are health and safety standards that go beyond the government. In the case of the United States, there's UL standards. In the case of Canada, there is CSA standards, NAM for Mexico, UE for the European Union. And these are really quasi-governmental companies, and the people you're selling to want to know, do you have UL ratings on your parts? Do you have NOM ratings? Do you have CSA ratings? For years, by the way, CSA is the Canadian Standards Association. CSA had stricter standards than UL. So we had to make parts to CSA standard because we wanted to be able to sell in Canada, which was stricter than the United States. And UL Underwriters Laboratory, brilliant company, spent a lot of time there talking to their people. Nice guys. They don't want to screw you, but they sometimes do. But they're nice guys. They actually, I really appreciate the fact that you send them a part and they will test the dickens out of it and they will tell you what's wrong, what's good, and they'll work with you. If something isn't, if you're not exactly passing a test, they'll help you to pass the test. They'll tell you what you did wrong at a cost, but they'll help you with this. So if your supply chain fails, all of a sudden you have to get a new part. UL or CSA is going to say, well, you're going to have to retest this again. If you're a small manufacturer and you're selling $100,000 of parts a year, and it's costing you $3,000 or $4,000 a year to maintain your CSAUL standards for each and every single part. Having to get a part recertified with a new part will take time, will take energy. You have to test this, and it's really biting into your bottom line. So the problem with tariffs is tariffs, if they force your company to spend much more money on new parts, yes, you can find an American supplier for that part, but now you have to test that part. You have to get that part certified. You have to do so much extra effort. So it's not just buy American or buy Canadian or buy Mexican. It's now your entire supply lines are screwed and you have to put effort you don't want to do. You have to take your engineering team and you have to reassign them to do all of the efforts. A quarter of my job practically was doing UL standards and certifications, and a tiny bit of my job was working on the harmonized tariff schedule. So when people show me this stuff about tariffs, the first thing in my mind is, been there, done that, I know this stuff. You're not going to pull the wool over my eyes. I can describe it to you in detail. So, pretty much my rant is over, but I just wanted to show people, say people, that manufacturing is the spirit of the world. It's I know that we don't we take it for granted, but I'm speaking to you and typing to you through my lovely little Pixel and my computer and my earbuds, and all of those parts are manufactured parts that came from one company or another company with parts that came from hundreds of different suppliers, uh, and they all work together because the system is functional. And if you start to throw monkey wrenches into the system, you can cause not just short-term hardships for companies, you can cause global recessions and depressions. So don't rock the boat if you can. One final note, my ex company that I retired from, they came to me about 3 years ago and they said, well, the 25% Chinese tariff is screwing us rotten. So we're going to ship production back to Mexico. So I'm laughing with these guys and my good friend, best friend in the company, whose name is Sal. Sal is talking to Sal all the time. Sal is always telling Sal's company secrets. And he's talking to me, and I'm kind of, even though I'm retired, I'm giving them little hints like, who they have to talk to, what they can do, what, to expedite processes. So the company shifted from China back to the Mexican manufacturers that they used 20 years ago. And now Mexico is going to have a 25% tariff. So um, hold
Well,
on to your
good
seats. It's going to be a
morning.
bumpy ride.
Good
Good
morning.
morning,
I think
Kim.
it is going to be a bumpy ride. A bumpy cold ride, and it's going to get warmer and warmer, and I predict that there'll be a lot more water too. um well, I've been reading the news about the tariffs, and a couple of the headlines were Mexico and Canada calls Trump's bluff. And I was thinking to myself, well, how did we call Trump's bluff when we agreed to the terms that he wanted in terms of putting troops by the border, the longest border in the world, which I think, you know, we're saying we're going to do that, and you know, I think it's probably impossible to do, um, but we've bought ourselves, you know, 28 days. What's going to happen at the end of this 28 days?
They're going to continue another 28 or 30 or whatever. They're going to just keep on rolling it over. And Trump is going to keep blustering. But the fact of the matter is, for exactly the reasons that I said, and I guarantee you, people are telling him this. You know, I'm sure there's a lot of people who work in manufacturing who are own businesses who are telling Trump's people that if you, you know, make this, if, even slight disruptions in supply chains, you can shut down the country, or at the very least, you can shut down assembly lines for weeks and months. And if you furlough workers, companies are going to take a beating, and the unemployment rate is going to rise, and we're going to be spending more money on unemployment insurance. So it's a terrible thing to do to an economy. And yeah, it's 10,000 new troops, but it's the same 10,000 troops that he got
Well,
a few
well,
months ago.
well, Sal, I honestly don't know if Canada has 10,000 troops. You know what I mean? Like deployed and ready to go by the border. I mean, you know, maybe, I know they're definitely going to have to hire more border security personnel.
It's
Um,
only to keep Americans out.
well, you know, yeah. And the thing is, I mean, you know, I didn't get to hear the beginning of your talk because I was a bit late. Sorry about that. But we all benefit, meaning North America, from our trade deal that we have, and that we give each other preferential access to each other's markets. I think Canada and America, like, I think, you know, 80% of our trade is with the United States, and I'm sure going the other way from US to Canada, it's over 50%. So we are so, I guess, interconnected and dependent on one another for our economic success, that I think putting tariffs on Canadian goods, although he did say for energy he would only put a 10% tariff, which I found kind of ironic, I'm sure. Um, it's going to hurt the American consumer. It's going to hurt the American business because they're going to pass those prices on to the consumers,
Of course.
and
And
and vice and vice versa, because Canada and Mexico will have to put up retaliatory tariffs. I mean, I think the right now premier of Ontario, Doug Ford, he was ready to put up, not even put up. I think he was ready to ban American alcohol in Ontario liquor stores. Like in Ontario, liquor used to be, or we have like a liquor control board, which is also like a retail outlet. And until a few years ago, that was the only way that you could buy alcohol in Ontario. So basically, they have a monopoly on it. Uh, I think about 5 years ago, they let certain supermarkets sell wine and beer, but hard alcohol is only through the Ontario Liquor Board, which we have stores. He was saying no more American liquor, which I think is in the hundreds of millions being sold um, in Ontario. I'll try to find the actual figure. So, I mean,
there are a few U.S. states that do the same thing, like New Hampshire.
okay, right. And I like it. You know, I didn't really like when they started selling alcohol in the grocery store. I've gotten used to it, and it is definitely more convenient. I'm fine with it because it is like cider, beer, and wine. But I definitely don't agree with hard alcohol being, you know, sold readily available, because, well, one of the key predictors of people getting addicted to something is the availability of it. So the, you know, the more available you make the alcohol, especially for young people, I think it has social ills associated with it. Anyways, um, so yeah, I mean, and I know British Columbia was also ready to put heavy tariffs on many American products. One of those was American alcohol as well. So that definitely would hurt a lot of the southern economies of the United States, the southern states that are sending up, Tennessee whiskey, or I think there's things that are coming from Kentucky and stuff like that as well. So
Bourbon.
bourbon, that's right, bourbon. The stuff I don't drink, that's for sure. But apparently
Well,
people really enjoy it.
I hate to say it, but it's almost impossible not to know about this stuff because you are flooded by advertising.
Right.
So I'm like, a 5 drink a year guy, but
Hmm.
I know all this stuff because I'm constantly seeing so much advertising on every media. So
Well, also, I
it's
don't know if
hard
people know
to
this,
miss.
but this issue about the tariffs and how politicians here in Canada are standing up to Trump is behind the Premier of Ontario's move, Doug Ford, to call an election. And this is like going to happen in, I think, 3 weeks from now. It's like a, I think he's using it because he feels like right now he's got the public support behind him because he's, I see many similarities between him and Trump in terms of like business ideology. I think the public was going a bit sour on Doug Ford because he's not an environmentalist. He wants to build more highways through pristine farmland and wilderness. I have a lot of problems with him, but the moment he stood up to what people thought was rightly so unjust, he gained some popularity. And now he's called an election basically on this issue of how we stand up to Trump's tariffs.
Well, the way I like to think about it is a lot of Republicans say that Trump is a unifying figure. And I agree. He unifies all of our enemies and all of our rivals and and all of our hurt allies.
Right. Very true. Oh dear. He's well, was just reading about where is it here? I have it on about what he's doing in terms of threatening people with their jobs. Like we're talking tens of thousands of people. It must be horrible to be a public servant right now in the United States. He's
I
creating
haven't.
like an atmosphere of uncertainty.
Well,
Um,
yeah.
let me see.
This is an old tactic. Is essentially what you want to do is you want to make everybody so frightened all of the time that you can just roll over them eventually.
Where do,
It's fear and panic completely overwhelms people, and now you can easily manipulate them and control them, or more easily.
right, right. There was a great write up about it in Heat Map, which I'm trying to find, but I can't right now. So just ignore me until I find it.
Which reminds me, I need to put something up on the Jumbotron. Oh, by the way, I accidentally YouTube. I'll have to find that. YouTube stumbled upon a really good video on how CO2 affects climate, and I gushed on it. I went on YouTube and I said, "Oh my God, finally, a really good video that in 12 minutes describes exactly how this works." So I'll have to find that later on and show that. But
Well, that yeah, if you could put a link up there, that'd be great.
the truth is out there. But I wanted to do something
Is
else
that from the
first.
X Files? Is that in X Files?
Yes,
The truth is out there.
yes.
Great show.
Let me
Scully.
add this link and
Well, we have a
paywall
lot to discuss
false.
today,
Yes.
definitely. Um, where am I getting it? Oh,
I
it's
put up on the
under.
Jumbotron. Heat kills. The study has just came out within the last 3 days that describes how many people globally are dying of heat-related, well, dying from heat-related deaths, and the numbers are increasing. Ex Heat exposure is critical, and it's because uh, okay, a lot of people say that so many people have died in the past of freezing to death and still die of freezing to death and die of overheating. But what all of those really are poverty deaths. People are dying of exposure because they don't have the clothing, because they don't have the fuel, because they don't have the ability to protect themselves, so they don't have housing. So heating and hot and cold deaths are poverty deaths. But to prevent somebody from dying of cold exposure, put on a coat. It's, literally, it's get better clothing. It's get them into areas where they can protect themselves. But heat deaths are different because you can't put on clothing to cool your body down. So it's not just a question of poverty causing heat deaths. It's a question of too many parts of the world where they don't have air conditioning available. And a lot of it is they don't have air conditioning available, not because they don't have the money, but because they never even thought it was imaginable that they would need air conditioning. So they don't have air conditioning in their buildings because they never thought it was necessary. It's the sudden heat waves that they've had in the EU. Paris had a huge one. London had a huge one. Moscow had a huge heat wave a couple of years ago that killed 10,000 people. It's because nobody had ever anticipated. Oh, Moscow, we don't have heat here. The Russian bear doesn't overheat. It freezes. So it's the unforeseen circumstances of building codes and regulations and living lives in ways that you never imagined you would have to because of change. Did I? Okay, let me throw that one in there too. I'm searching for I every week before we do these, I generate several charts that I think are going to be useful or to help to narrate the story. And let me add another narration chart. And this actually has to do with topic number two, which is Hansen et al. 2025. I have to get used to saying 2025. And
Funnily enough, I've been right on that. You know, when you have to write, well, not that we write anything nowadays, but when I actually do, I'm putting 2025 instead of
oh, that's what
2024. So it usually takes me a couple of months to do that, and I think it's just because it's 2025.
I don't mean like on checks. I mean talking about papers.
Okay. Oh dear.
So let me pop this out. Difference in land versus ocean. And we've all, we've all been told that because of the way oceans are, oh, I hate to say it, fluid, uh, water has this amazing ability to sink or, or rise. So as water heats, water is, everybody, we're taught from, childhood, hot air rises. Actually, hot air doesn't rise. What happens is because hot air is less dense, hot air travels upwards because there are fewer molecules per liter. And as a result, hot air displaces less uh, area than cold air. So 1 mole of hot air uses more liters than 1 mole of cold air, and so the hot air therefore this is a branch of mathematical statistics where damn, I actually had a conversation about this yesterday, where statistically, because the molecules are using less oh God, what's it called again? Uh, the mean distance between molecules is rising, so therefore it goes up because the mean distance between the molecules uh, has increased. Uh, so at this moment, for the last 50 years, global mean land temperatures have increased by, uh, I'll round it up, 0.35 degrees per decade, which means that in 50 years, land temperatures, the air temperature above the land has gone up by 1.7 degrees C, 1.75 degrees C. And just the last 25 years, global land temperatures have gone up by 0.44 or 1.1 degrees C in 25 years. So when people say, "Oh, well, global warming is taking," it's a very gradual process. Oh my God, it isn't gradual. When temperatures are rising this rapidly, it causes complete and total chaos across all systems. And some of those systems are, of course, biological in nature. I've been told, I didn't know this. I'm American. How am I supposed to know this? That the UK had a horrible crop last year. That a lot of their cereal grains, they just, you know, did a terrible. It's funny because the United States had the opposite. The United States had a very, very good, record-breaking crop on wheat, corn, and soy. So naturally, with record-breaking prices, sorry, record-breaking crops, and the lowest uh, spot prices in 5 years. Essentially, that's companies go and they say, "I want to buy a future for 100 pounds of wheat." They can take physical ownership of that 100 pounds of wheat, but essentially they're buying a futures contract, a promise to own that 100 pounds of wheat. So the futures contracts are the lowest they've been in 4 years, which means that corn, wheat, soy are the lowest we've had in 4 years. So why don't we see cheaper food prices? I mean, if the raw materials are cheaper, why aren't we seeing cheaper food? Because companies are like, yeah, we're happy charging you this much. We're going to keep on charging you even if it costs us less because you're going to pay, you're willing to pay it, so we might as well keep going. Capitalism at its finest. So, when do we start? I think I might as well and start to talk about the first. My rant shouldn't be considered a topic. So let's talk about the first
What are we
topic,
going
which
to
is
talk about next?
our subtopic,
Can I
and
just
that's cancer.
can, okay, yeah, sure. I mean, I that ties in with the recent news about the Arctic. Apparently, in places in Norway, they're measuring temperatures 20 degrees Celsius above normal
Uh,
in the winter, of course, because that's what we're
I
in.
I've never subscribed to it because I'm not going to call myself an Arctic scientist. I'm not going to, overstate state my facilities. But I've been a fan of the Arctic Sea Ice Forum, and I should post that up. It is my go-to whenever I need to know anything that's happening in the cryosphere. Cryosphere, of course, frozen sphere, which is uh, north, the Arctic. It is the Antarctic. It is glaciers. It is any part of the world covered by ice, full time or part time, is part of the cryosphere. And the Arctic Sea Ice Forum is my go-to when I need to learn what's going on and to find out what's going on. So I'm always on those forums. I lurk. I don't talk because again, I'm not an expert on it, but you learn a lot there. And someone had mentioned yesterday that Svalbard in Norway. Uh,
Yes, that's right.
it's literally in the middle of the Arctic, and in the Arctic Sea, it's some of the highest latitude uh, human human cities encampments is on Svalbard, and they reported yesterday that the water temperature was plus 5 degrees Celsius. which is 41 degrees Fahrenheit. That was the water temperature. And everybody on the forum is like going,
That's bath water. That's practically bath water.
and we're all in shock when when you hear those kind of temperatures time of year. That's the kind of temperature that you might get over there in early May. That's when you normally would see those kinds of temperatures, and now they're seeing it in early February. So it is the world turned upside down. The cryosphere is. I put out the chart. We're number one. Uh, we currently the amount of global sea ice that is out there for this date. I think it's just a hair under. Let me see if I can find my own. A hair under 16 million square kilometers of sea ice. That's Arctic and Antarctic combined. So the average for the data set starts in 1970. It starts in November 78. So we'll call that 1979 because there wasn't a February. There's no February data for 1978. The average for the entire data set is 18.1 million kilometers square, and we're at 15.997. 16, it's the lowest ever. It is just a little bit lower than 2023's 16.04. So, yes, we are at the lowest global sea ice extent. Oh, God, should I go into sea ice? I'll be quick. Okay.
Okay.
I'll be very, very quick. There are four metrics for sea ice. The one that you hear most of the time is sea ice extent. What sea ice extent means is 15% of every kilometer covered by ice is listed as sea ice extent. So if you have a kilometer and only 15% of it is covered by ice, that's considered covered. Uh, I don't know why they decided 15, although some indexes use 5%. Then you have sea ice area, which is, I think, a little more realistic. So, because if you take a photograph and you look at all the reflected areas, you add those up. That's your sea ice area. Then you have sea ice thickness. It's a little more complicated because it is hard to measure, but there are ways to do it based on microwave emissions. You get sea ice average thickness. And then you have the combination of it, which is sea ice volume. How much is the total amount of sea ice volume? This is mostly a northern hemisphere thing because Antarctica really screws things up. And the reason why it screws things up is in North America, we don't have any permanent, we do have glaciers, but we don't have any permanent glaciers that extend really far out into sea. The West Antarctic is all permanent glaciers extending far out to sea. So it's harder to measure West Antarctic sea ice volume, sea ice thickness, but you can still measure sea ice extent. And that's a number that comes out roughly in, I don't know, 4 or 5 days or 2 or 3 days, depending. It's called biomass. It tells, and that, we're all waiting for the biomass January number because nobody had possibly predicted that biomass January might be the lowest in history for 2025. But then again, nobody predicted that January 2025 would be the warmest air temperatures for a January in history. So we're all scratching our heads here. We're in uncharted territory. The world is definitely hotter than we had anticipated it would be for this time of year. And Hanson.
Oh, I did want to mention. I did. Can I just? I'll just. Can I just
Sure,
say
do it.
two things before? Okay. Well, one, I
Do
was
whatever you
looking
want.
exactly what you were saying about January. Zeke Hossfather, he tweeted that January 2025 was quite unexpectedly the warmest January on record at 1.75 degrees Celsius above pre-industrial, beating the prior record just set just last year. And this is despite the presence of La Nina in the tropical Pacific And then with the El Nino event of 2023, 24, long faded. And this, I think, is a great segue into the paper by James Hansen, which was just published, I think, 2 days ago. In it, he claims that the world is on track for more than 2 degrees Celsius in warming by 2025. So he's, officially coming out and saying that the 2 degrees is dead, that we won't be able to limit, at least in the, I guess, medium long term, the 2 degrees Celsius global mean temperature rise, which has many dire implications and consequences to it. Hansen has been saying for some time that the current climate models underestimate the rate at which global temperatures are rising. This new research, published in the journal Environment, Science and Policy for Sustainable Development, which means that it is a peer-reviewed article, says that we have been artificially cooling the planet with aerosol pollution for years. With new shipping regulations limiting these aerosols, this cooling effect is decreasing and warming will ramp up rapidly. They're suggesting by 0.2 or 0.3 degrees Celsius per decade. Unless actions are taken to reduce global warming, this is one of the most dire predictions of the study. They believe that the AMOC, the Atlantic Meridional Overturning Circulation, will likely shut down in the next 20 to 30 years. So, yeah, that's where we are right now with this article. I have to commend the authors for explaining the science. Like they really want to communicate to the public
Yeah,
what's going on.
I do agree that they are doing an excellent job of trying to tell people what's happening.
Right. And I think, well, I did put a link up in case people haven't read the article. There is a link up in the Jumbotron, and I think there might also be a link to the video, because the video is excellent as well. They on the day that they published this article, asking, is this, I forgot the name of the title of it, but are we, is global warming accelerating, and does the United Nations and the world know about it? It's something like that. They had a Zoom meeting explaining, and they streamed this on YouTube, and then they posted the video on YouTube explaining, the science behind it, showing all the graphs. Jeffrey Sachs was interviewing them, and each of them went into detail. And what I liked about it, about James Hansen's talk, was that he really went into the history of climate change, into
Mm,
paleoclimatology, um, into philosophy a little bit, and also into like how young people are capable of understanding and bringing about change, and he's actually offering solutions as well. So I would highly recommend that people watch the video and also read the article. But I guess we should dive into it. Where should we begin here?
very, 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 very quick. Yeah, we are going to one of these weeks. We are going to do a history of paleoclimate science or climate science. We were talking about this last night, and yeah, we are going to do it one of these weeks. I don't think we're going to be going over any new ground per se, but we always have a rotating cast of people joining us, and so and it's always good to have refresher courses. So we are going to do it one of these weeks soon. All
Good
right,
idea.
the first thing I'm going to discuss is the issues I have with the paper. And the first issue that I have with the paper is he's describing the temperature difference between 2022 and 2024. And it's okay to do that. But if you're ignoring 2016 and 2020, what you're telling me is that this gigantic jump in temperature is brand new when it isn't. Uh, we historically look at climate as a 30-year moving average, slow, steady. I never like to use anything less than a 5-year moving average when I talk about trend lines. And now he's talking about individual year jumps. And I think that's not solid science. And there's reasons for that. And obviously, the biggest reason for that is so much of our climate is influenced by um, the ENSO patterns. That's the El Nino, the five El Nino regions that are, if you were an alien coming to the Earth for the first time and you're flying toward the Earth on your spaceship, your name for Earth would be Pacifica because that's what you're going to see in your spacecraft. You're not going to see a tiny little bit of land in North America and a tiny little bit of land in Africa and a tiny little bit of land in Asia. You're going to see the Pacific Ocean because it is almost half of planet Earth's surface. So changes that happen in the Pacific and the Indian Ocean are what uh, moderates global temperature. There was a chart I put out a couple of days ago. We just had a fascinating situation where after three consecutive La Nina winters, we had in 2023, 2024, the first El Nino winter. And that's why temperatures exploded. So it's not just that it was the change in sulfur dioxide content. It was the change in ENSO, and that is you have to consider how that works. Is the Earth is constantly what I was saying earlier about water temperatures, how the hot air rises, but hot water doesn't rise. Hot water sinks in order as water percolates, you get a transmission of the hot water goes down to be replaced by cold water. There's turbulence, there's convection mixing. So what happens is that the Earth acts as a battery. It warms up, and then something happens. There's so much discussion as to exactly what is it caused by. Is it caused by lunar solar tide cycles? Is it caused by some sort of a relaxation excitation circuit? Is it caused by any other? We still don't know exactly. We think we're getting it, but anytime a paper comes out, and I've actually had been given papers to review, and I said, all right, I'll take a look at what this says, 6 months from now. And 6 months from now, every paper I've ever been given about ENSO it turned out being wrong. Every time they try to predict long term, doesn't pan out because there is still a lot of randomness in the system. And again, the randomness was we had three consecutive winters of La Nina. And then all of a
Excuse,
sudden, we have an El Nino and temperatures explode. Yes.
well, he was right about the 1.5. Like, didn't he predict that like a couple of years ago? And the IPCC didn't back him and wouldn't. I don't think they would publish his report. And now, I mean, I think most
Well,
scientists would say that we've reached 1.5.
but we've reached it, but that doesn't mean we've breached it. And
Um,
because again, what we talk about 1.5, we don't talk about 1.5 for 1 year. We talk about 1.5 on a 30-year moving
right.
average.
That's true. That is true.
So that's
But
why again I have my issues. If next year is 1.48,
well,
what do we say then?
well, I think he's
If this year.
making, he's making the argument or presenting very clearly, I would say, that we won't be going back from 1.5. And like it says here, I think it was for 17 months, um, we did hit 1.6 C mean temperature increase. for 16 or 17 months straight. And I know you have to look at the historical average, and it's generally considered to be 30 years before we breach it. But, we're only 5 years from 2030, 25 years from 2050. I mean, if we're going to call it in 2050, it's probably going to be too late. Um, from 2070 to 2010, 0.18 degrees Celsius per decade temperature increase. 2010 to present, it's
It
double that. It's
I,
double that. That's
it would
accelerating twice as
it would
fast.
it would really help if everybody had, because I you're reading off of the Columbia EDU website, right? On the Hanson PDF.
Well, it's just notes I took, yes, but it's
Okay,
from
because you got the notes.
his paper.
I've got the paper in front of me, so it really
Oh,
helps
you
if everybody
okay?
has the paper. But it's so
Okay.
you don't have to you don't have to have this at home because I'm
No, I
looking at
actually,
that.
well, I did put it in the like I said, in the jumbotron. If people want to open it up and ask questions about it, or something like that, or just follow along. I mean, he also does say that the temperature jump that you're talking about, the 0.4 degrees Celsius. He says half of it is due to the tropical El Nino warming events, but then where's the other half coming from? And it
Okay,
uh,
if you look
uh,
at the charts,
according to him, it's because of the changes in the aerosol emissions by ships.
if you
Um,
look at if you look at the chart, first things first. Uh, you've got on the light. There's two. Is that light green or
Sal,
light
which
blue?
charts? Which charts is
Uh,
it?
figure one,
Figure
right
one.
at the
Okay,
beginning.
thank you.
Figure one. The
Is
first thing you
everyone able
see.
to follow along? Um, with the article? Does everybody have the article, or does anybody need me to? Maybe I could find it and put it independently into the pill, because I know I have it attached to something else. But there is an article there.
I can try to do my best Fiorello LaGuardia and
What's
that's a
that?
New York
That's in New York,
reference.
LaGuardia
Uh,
Airport, right? But I don't.
in the 1930s, there was a newspaper strike, and so nobody was able to get their funny papers. And so the mayor of New York would read panel by panel all of the cartoons so that people could follow with their cartoons.
I bet you he was a very popular mayor. Mayors just
You,
don't do that
that's why
anymore.
we named bridges after him.
Oh, the good old days. If only we
So,
were alive then. When we were at what, 310 parts per million, or
oh,
300 parts per million, maybe.
we're a little more than 300, but not much more than 300. And by the way, that was a weird period also because we stabilized for almost 18 years. There was only a 1 ppm difference in global CO2 levels. Part of that was World War II. Part of that was the recession. Part of that was World War II. Part of that was the aftermath of World War II. If you look at the chart, the first thing you see is the 12-month running mean. Then underneath that, you have the 132-month running mean. Now, why do we use a 132-month running mean? And that's because that corresponds to the 11-year solar cycle. And by the way, the solar cycle is not exactly 11 years. Is there anybody here who doesn't know that my username 25 cycle deals with the 25th solar cycle? In case anybody
We
ever wanted to
know,
know.
we know.
So the 11-year, so this we are in the 25th known uh, observed solar cycle. We are beginning the 6th year. We're 5 years through. We're beginning the 6th year. Uh, we are at a solar max. So solar max is at about 5/100ths of a degree. Solar mins at a subtract about a 4 or 5/100ths of a degree. So this also plays an active role. So you were wondering where did where that extra 0.1 degrees come from? Well, a good chunk of that 0.1 degree is solar maximum. So that needs to also be brought into the picture. Uh, there is a cycle 25 so far to date is about 1 part in 7,000 stronger than cycle 24. So that just goes to show how little the difference is. It's one part in 7,000. But that's good for 1/100th of a degree also. The fact that 25 is stronger than 24. So you have the solar max event going on top of that, and that's part of the difference. So there's a lot more in play than just CO2 levels. Um, Nitrous oxide is relatively stable. Methane is going through the bloody roof. Methane is absolutely just blowing everything else away. I don't know. Oh God, this hurts. What hurts is the fact that the only place the only organization that is really measuring global methane is NOAA, and now Trump is going to shut down a lot of NOAA's faculty. So a lot of the data that we need to know is going to be hidden from public view. I'm sure they're still going to take it. They're just not going to tell us.
Oh, just as an aside to that, I found where it was climate pages removed from government websites. Government websites are being scrubbed of references to climate change. So far, pages have stopped working on websites for the Departments of Defense, State, Agriculture, and Transportation. A climate change loading page for the White House does not load. Climate scientist David Ho noted that the page charting CO2 atmospheric trends has been removed from the NOAA website.
Hang on. This is a big hang on. NOAA had a 48-hour scheduled maintenance
Oh, okay, okay. So it might not be as bad, but I'll try it right now.
because I just checked on the GML website, and the GML website is back up. So I was able to get my CO2 daily fix. And this is a known issue. And the reason was the hurricane that hit North Carolina. NOAA had a
Right.
lot of has a lot of their facilities in North Carolina, and the one town that they thought, oh well, this is going to be safe. We're never going to have a hurricane or earthquake or a tornado on this town. Yeah, it got hit by the worst hurricane in a century. So they actually had to rebuild some of the electrical grid in North Carolina, and now it's back up.
Actually, I think it is back up, so that it could have been that the global monitoring laboratory is up, and they've got the parts per million CO2 for December 2024 up at 425.40. So maybe it was what you were talking about, just a glitch.
I should have I haven't been broadcasting this to people, and I actually apologized yesterday to one of my friends because I didn't tell everybody, but I've been telling a few people about this, so there were people who knew, and I warned them a couple of days ago. I'm like, if you need any data, get it now because for 48 hours, NOAA is going to be physically down. So yeah, I know this is a difficult thing to talk about because there's a lot of panic in the air. And in this case, this was actually not the end of the world. The rest of the end of the world is going to happen soon enough.
All the
Uh,
rest is
I-
probably pretty accurate, though, about the
yeah, I
different
am.
websites and the scrubbing of like
Yeah,
climate change from the for the websites. It's quite Orwellian, quite 1984.
let's just say that for non-scientific websites, the data is being purged. So for public
Which is
access,
right, which
worse.
is very harmful because that's where people might learn about it and might see it, right? When they're not necessarily looking for
Everybody wants a stupid country.
it.
I've said this actively for a while now. The reason why all these billionaires and well, not quite trillionaires, all these 100 billionaires love Trump is because it's so easy to manipulate a stupid man, but it's very hard to manipulate a smart one. And they want
Okay,
a stupid president.
you know, I mean, I think if he didn't have a TV show, he never would have gotten elected,
No, never, never.
right? And
What was that, Mark
I
Jacobs?
think for a long time he probably, back, let's say in the 90s, he was a likable figure. I hate to say that, way back in the 90s, but as time wore on, he became. Well, I don't want to talk really want to talk about it on it, but yeah, I mean, he is what he is.
Moving on. Yeah. So yes, the data is back. The data is going to be harder to get from on non scientific websites. I don't think they're doing anything with NASA. NASA is going to be even harder because NASA's missions go into a lot more complexity. There's a lot more components to NASA, JPL, and they're doing work. Also, we have a lot of international partners with NASA, more than we do with NOAA. Although I did see that they're trying to shut down all international cooperation between NOAA and other weather bureaus. And the next step then is EU with the Copernicus system. ERA 5, Copernicus, they're like, one step below NOAA and NASA, but they're not bad. So they don't have, the extensive database, but I trust them for data as much as I do NOAA and NASA. It's just that they never learned how to write a web page or understand how to. The data is harder for the average person to get, but you can get it. It's just a bitch because they try. ah, when you try to give people a million different options, and because you do a million different options, it's harder to get the one you want because you have to wade through all of these mountains of bullshit. That's the problem with the ERA 5 website. You can't just very easily get what you need. You have to really push hard. But there are other alternatives. Oh, I might as well start talking about the other alternatives.
Well, Sal,
Uh,
I'm just
yes.
looking, just to go back to the article.
Oh, yeah.
I'm
Hansen.
looking under climate forcings, and he does a nice explanation of the sun, and saying exactly what you're saying, reinforcing all that, um, explaining the variations in its brightness, and the forcings change between a solar minimum and a solar maximum. Quoting, he says, "This solar forcing we will show is much smaller than human-made forcings, but large enough to be a partial cause of present climate extremes." So yeah, you're going along with the climate science there. He talks about volcanic eruptions producing large climate forcings, and I'm surprised about this. He goes into paleoclimatology, and he talks about the aerosol effects of biofuels and wood. And apparently, in the pre industrial era, um, these aerosols contributed, was it like 0.5 watts per meter square to the climate forcings? I think that's
I
what
lost the
he.
last 30 seconds.
Oh,
Sorry.
that's okay. I was just saying that no, I was just saying he was saying that through burning of wood and the aerosols produced, or the sulfates, I guess, produced. No, it would be the aerosols produced from that in the pre-industrial era. He was saying that that would be um, responsible for 0.5 watts per meter squared. Does that sound correct? I can't find it at the moment. That's just off of my memory. Um, but then he's also
uh,
made.
Negative. The removal of a negative force.
Yes. Yeah. Well, then, and that, oh, that's yeah, we've got to get into talking about the negative forcing, but I think he's making the case that El Nino contributed to half of this warming that we've seen, but that other climate forcings must have contributed to it as well. and it has to be the part that doesn't have to do with the sun, and that means it's due to human caused forcings, which is either greenhouse gases or aerosols. And then he explains how the aerosols historically, have been counted for by human activity and exacerbated by like deforestation and human agricultural activity as well. But I think would be helpful to me and probably to some of the listeners is talking about how, if you could, how these aerosols, the sulfur, the sulfates, how like what role they play in cloud formation, which also he makes the point that the IPCC doesn't account for this in their estimates, and how
Um,
okay, yeah,
oh,
so
oh,
thank
yeah,
you.
I can. I'm sorry, in the middle of nowhere, I just got an ad on my screen. I thought this was supposed to be a protected space. Uh,
I think we need some more
uh,
aerosols maybe.
um, okay, there there are a lot of problems with the aerosol explanation, and I'm going to mention that my two favorite working climate scientists, working on an everyday basis, they're not paleoclimate scientists, paleoclimatologists. They're working uh, modern uh, modern climate discovery resources discoveries explanation is Robert Rode and Zeke Housefather, who you've already mentioned. They are two PhDs who are loosely affiliated with Berkeley Earth, the best team. And I they are my go-to for pretty much anything and everything in the climate realm. And they both are extremely skeptical on sulfates and the negative aerosol forcings, and so am I. I'll explain why. This SO2, sulfur dioxide, is a relatively heavy molecule. Because it is relatively heavy, it doesn't disperse as much as some of the other molecules. Also, because it really likes to interact with water to form H2SO4, sulfuric acid, it has a shorter life expectancy than many of the other molecules. It's similar to the way that methane doesn't like to stay CH4. Methane tries to oxidize and become CO2 and water. So sulfur dioxide isn't as broadly spread as other molecules. If you look at a global picture, and I've been trying, and there is no global data on this. There's only single location data on this. It doesn't go everywhere. But a bigger and more important aspect of sulfur dioxide to me is the fact that when we talk about a positive forcing, CO2 or H2O or CH4 or all of those molecules, uh, what they are doing is they're trapping upwelling IR from the Earth heats up, the Earth emits IR. One of these days, we're going to have to go into greater detail about this. Probably when we do the paleoclimate, we'll do the paleoclimate stuff, the history of climatology, and we'll talk about that then. So the Earth gives off IR, and these molecules absorb IR, and they give some of it back in radiation. They give most of it back through collisions with other molecules. So they heat. This is how quote heat gets trapped. It doesn't really get trapped. It gets slowed down, and sometimes it gets dispersed, and sometimes it gets emitted. So, but that's literally 24/7. So a molecule or the molecules of CO2, uh, they're the hardest working molecules in showbiz. They are working all the time. It doesn't matter if it's sunny outside, if it's raining outside, if it's ice storm like I've got right now. It doesn't matter if it's day or it doesn't matter if it's night. Those molecules are absorbing IR all of the time. Sulfur dioxide only reflects uh, sunlight when the sun is out. So it's much harder to calculate the effectivity. Solar reflectivity is based on incident angle. It's based on how much you have. We also don't know we don't have a forcing calculation for SO2. So to me, if you don't even have a forcing calculation, if you can't even tell me what happens if we double the amount of SO2 or halve the amount of SO2, that runs a gigantic red flag. That's telling me that the only way we can do this is through modeling. And it's very hard when you have a multivariate situation such as we have now to be able to remove just one variable and stick that aside and say, okay, now what else is happening? So that's why so many other scientists are talking about the aerosol reduction. And we're saying, hang on, it's probably not this big, and we have no absolute information that it is this big. So this is all based on modeling, and there's nothing wrong with modeling, but it also depends on how you run the model, and we can't easily run a model on SO2 again because one, we don't have a full forcing function on this. For years, we've been talking about what are the effects of clouds on climate. And,
Well, excuse me,
you know,
Sal.
yes,
Um, okay, so it seems to me, based on what you've said, is that you follow more the IPC model, in that you think we should have direct measures of these different climate forcers. Am I correct
I,
in?
I follow the scientific method in that you cannot attribute an unknown variable just by using models that you then control.
Mm-hmm.
We need to do the research to be able to figure out exactly how this works. And I tell you, I know how to do some of this research, but oh my God, does it take an incredible amount of information and data. What we have to do is we have to have global monitoring of SO2 literally everywhere. Every few, kilometers, we need to have monitoring stations. We need to have monitoring stations not just on the XY axis, but also in the Z axis. We have to know exactly how much is going, what's the concentration of SO2 at 2 kilometers high, 5 kilometers high, 10 kilometers high. Then we can couple that information with series data, which I mentioned earlier, with what are the frequencies of sunlight coming in, getting reflected back, what are the clouds doing, what is the IR going back out. So in order to accurately figure out what's going on with SO2, we have to measure it. And then we have to compare it not just on because again, SO2 is unlike CO2. It's not a 1D model. It is a true globally coupled model. It requires a three-dimensional model of the atmosphere. So we need to have that
Well,
three-dimensional information on.
I mean, from the way I understand the article, is their evidence of the effects of the aerosols can be seen by the satellite images along the shipping routes, the northern shipping routes, that, prior to the massive reduction in the sulfates and the shipping fuels, and post 2020, when there was a 70% reduction in the sulfates contents of the shipping fuels, which also led to a 15% reduction in aerosols globally. So, I mean,
which is
um,
which is why I released that chart this morning
Okay.
on showing the difference between NOAA land and versus NOAA ocean. And it's not just that the land is increasing by essentially uh, an additional 140% faster than the oceans. It's also what's happened in the last few years. And ocean temperatures, partially because ocean temperatures, by their nature, are very slowly varying. The ocean doesn't like change. It's the capability for the oceans to store heat is 1,100 times greater than the capability of the atmosphere to store heat. It's because the mass is so much greater of the ocean. What is ocean? Hydrosphere. The hydrosphere is just so much more massive than the atmosphere, and also because water is a much more dense molecule. So it's um, the ocean doesn't like to change. Now we're talking about the light that's coming in because what this is doing, SO2 is blocking reflections.
Right.
The problem is that, again, it blocks the reflections only at a certain time of day. You're not getting incident light coming into the oceans at night. You're not getting incident light coming into the oceans during the winter. You're only getting light coming into the oceans for the most part during the summer, during the daytime. And that's why this becomes a lot more complicated issue, which is why we need to do this to really figure this out. You cannot
Right.
just do this on even a gridded scale. This needs to be done on a gridded scale over time. So give me a team of 5 or 6 good scientists. I still need to get the data, and some really, really good mathematicians. And yeah, I could figure out how to make this work, but
Well,
we still don't have the data.
um,
We don't have the granularity of
right.
data
Well,
necessary.
and I think that's one of Hansen and Al's, critiques is that these aerosols, they have direct and indirect effects on solar radiation and also indirectly on the clouds. Um, and that's
And that's and that was I was going up the graph. I was about to discuss clouds, and I have I've looked at clouds from both sides now. I need an audience here that knows '60s music more. Uh, Both sides by Joni Mitchell.
okay.
And clouds, the biggest issue has always been boy, this is going back 15 minutes ago. Do clouds heat the atmosphere? Do clouds cool the atmosphere? What is the overall forcing effect of clouds? And the fact of the matter is, it is so small, we still don't know if it's a positive or a negative. We think it's a positive. We don't know for sure. So the best data that we have seems to indicate that more clouds means warmer Earth. This is kind of what I mentioned last week, how the warmest days in the winter are the cloudiest days in the winter. And the coldest days in the winter are the clearest days in the winter. Because during the winter, those clouds block heat from escaping, IR from escaping. Uh, if we think about how long in the year we have full sunlight pouring in on the earth, especially if you're, 40 to 45 north, as many of the people here are. So if you're from between 40 to 45 north, and whatever, part of the world you are, which is like the population band, so to speak, you have bright sunlight, 1,200, 1,300 hours a year, and the other 7,300 hours you have either dim sunlight or you have darkness. So the aerosol effects, at least for clouds and for SO2, is hard to calculate. So I am so, by my nature as a scientist, I am extremely conservative. I need to have tons of data, which reminds me, I spoke to a friend of mine who is now working with the paleoclimate teams. He said he'll try to seek the information as long as I don't pre-publish, and I would never do that. And it's not because uh, I'm looking to put stuff out that nobody's ever read before. It's because I'm the most goddamn curious person on the planet. I really love to know stuff. I always want to know what's going on. And so I'm pouring through all of these old papers because to me, learning how the universe works, it's the blood that, pours through my veins. So
Okay,
when I
Sal,
see,
Sal,
yeah,
Sal. Okay, we got to talk about the cloud nuclei formation because well, I mean, I understand the sulfate particles, they're big enough that they'll lend itself to forming clouds, right? Like I've even read recently that microplastics might lend themselves or likely do lend themselves
yes,
to cloud formation. Um, so, I mean, it does seem very plausible that if we have something that lends itself to clouds being formed, um, that if we take that away, plus increase the temperature of the Earth, because I think a warmer Earth equals less clouds, that we will have less clouds and we will have more warming, and that part of that has to do with the Earth's reflectivity or the Earth's albedo.
um, going back to what I mentioned earlier about series data, one of the most important of the series data is called cloud area fraction. And they actually spread this into several different types of cloud area fraction. And that's exactly what it sounds like. How much of planet Earth is covered in clouds? And right now, it's about I don't have, yeah, that's close enough. I'm looking at my chart. The 12-month moving average for cloud area fraction is right now 67.3%. And if I go back to 2001, it was 68%. So actually, the amount of clouds has decreased. But it is, but one of the highest cloud area fractions in the entire database was a few months ago, where we had a 69.2 cloud area fraction. So the amount of clouds that are in, and that's a 12-month moving average. That's not a single month's data because you want to always look at um, averages rather than just individual months. So if you ask me, do we have more clouds than we had 20 years ago? The answer is no. They're about the same. Do we have darker clouds than we had 20 years ago? And again, the answer is marginally darker, which is actually in some respects worse because that means that less sunlight is reaching the surface and more sunlight is being trapped or reflected. Uh, I joke about this is why I've lost all of my hair. It's looking at series data. I've been studying this stuff for about 3 years solid every single month, and the more data that comes in, the more, or I should say, the less certain. I mean, this is you see the old Dunning-Kruger curve, how people who don't know what they're talking about are have no information but are very very sure about it. I have a lot of information, and I haven't got a clue what's going on. So
Okay,
all of, all,
well, wait.
all of this is contradictory.
Let's go back to how aerosols, particularly SO2, are a negative forcing, and this SO2, is that a precursor in the fuels or is it an actual aerosol?
Oh, oh no, that is. Garbage.
That's garbage. Okay.
Uh, what every most of your by the way, that's another discussion we can talk in the but there's a reason why we have reduced amounts of SO2 in our emissions. That's sulfur dioxide, and sulfur occurs in every form of oil, especially coal. There's a little bit of sulfur in natural gas. When you see them flaring natural gas, what happens isn't they hit a pocket of natural gas where the sulfur is so spectacular. It's just more expensive for them to clean it up than it is for them to just burn it away and get rid of it. So a lot of times when you see those flares, it's just they hit a very, very high sulfur. And that flaring, because it's burning sulfur dioxide, is actually uh, cooling the atmosphere. So it's weird because you got this. We're releasing methane, which is the one of the worst greenhouse gases. But we've been burning the methane, and some of it doesn't get burned, so you're still releasing CO4. So you're creating CO2, you're creating SO2, you're it's parasitic losses of CH4. But the net result is flaring actually cools the planet. It's so crazy. Uh, which is why sulfur dioxide, for all practical purposes, it's another one of those wonderful little three atom molecules, and some wavelengths of light, uh, because of the shape of the angle of the two oxygens to the sulfur, some uh, frequencies of light get reflected by it. So instead of the light either passing through or being absorbed, it gets reflected. Any incident light striking a sulfur dioxide molecule will try to go literally back the way it came. So it's like a gazillion tiny mirrors. A sulfur dioxide cloud is, for some wavelengths of light, it is a mirror. How it cools the planet down is because it's blocking the amount of sunlight going through. It reduces the amount of sunlight from the top of an atmosphere reaching the surface. It changes the planet's albedo. It raises the planet's albedo. Albedo is the fraction of light that gets reflected. That has changed. Oh boy, now I got to go off my albedo chart. Albedo, where are you? Uh, the last month's data that we have, albedo is this lovely round number of 0.2900. It's nice to have a round number. It's 29%. That means that on average, looking at the entire planet, if you could, somehow, condense the entire Earth into one little dot, 29% of the sunlight that strikes the atmosphere comes back out. Now, once upon a time, in 2009, for some reason there was a blip and it was higher. It was 29.4%. So there is a sizable difference between 29.4 and 29.0. More light is coming in than earlier. And as recently as 2003, oh boy, this really actually was quite big. In May of 2003, just before all hell broke loose, albedo was down to 29.3, or I should say up to 29.3. It went down to 28.95, 29. So that's in, uh, in raw numbers, that essentially means that roughly 1% more light came in than used to come in. Actually, I shouldn't say it that way. That's a bad way of putting it. A better way of putting it is 1% less light reflected away. So albedo does make a huge difference in the Earth's adaptation to sunlight and the way the Earth responds to sunlight. It is the way the Earth responds to sunlight. It is albedo. Sulfur dioxide increases albedo. It makes the Earth more reflective. It causes more light to bounce away. Reducing the amount of sulfur dioxide is going to create a change in albedo. But uh, it's a gradual change. It's we there's a lot of things involved here because we don't know. I have data on sulfur dioxide, and it's poor and it's weak and it's only single location and it's not. Again, to really know what's going on, and this is where I have fault with Hansen. To really know what's going on, you need to have a full three-dimensional map. And it's not just the XY axis, you also need to know the Z. You need to know what it is like in 10 miles high, 20 miles high, 50 miles high. So, and this is exactly the wrong time in history to do this because the Trump administration doesn't want to study climate. They don't want to study anything. These are know nothings who do not believe that information and research make a difference. We need to have uh, Copernicus pick up. We need to have the Japanese meteorological agency pick up the ball. We need to have HADCRET pick up the ball, the Met agency.
Right.
We need to have the rest of the world, while the United States has ceded the lead in science research. And by the way, obviously,
Well,
China
well,
is going to pick up the ball.
well. In the paper, Hansen talks about the Earth's albedo has gone down since 2000, and that the percent sulfate um, in the shipping fuels has slowly been decreasing since about 2010, but it had the biggest change in sulfate content in 2020. Um, he says that there's been an increase in absorbed solar radiation. In 2020, it was markedly so. And this is what they're kind of using, I guess, as like a proxy um, to measure the decrease in sulfates in the northern latitudes where the shipping routes
Yeah,
dominated.
but albedo went shooting back up to 2022. That's where I have fault with his conclusion
Yeah. Well,
because
he also talks about
it's
the sea surface temperature in the
oh yeah,
30 degrees
that's a shock.
latitudes, right?
That's an
Like
absolute shock.
that increased rapidly after 2020. So that's another one of their arguments. They say it was caused by the sulfur limit on shipping fuels over the last decade. The Earth's albedo decreased by 0.5%. Ship aerosol forcing largest in the northern shipping routes. In 2020, there was an increase in absorbed solar radiation, especially along the shipping routes. Again, the sea surface temperature in these northern shipping routes rapidly increased after 2020. And, quote, high latitudes contributed as much to global warming as the tropical El Nino in, I think that was like 2024. He claims that temperatures won't go down in 2025 because the air is getting cleaner. And there's an interaction with the cleaner air having less albedo, and and then the problem that's occurring is the AMOC slowdown and also the melting ice, and that it gets into another, I guess, controversy that's going on within climate science is how much climate forcing does the freshwater melt have from the glaciers, and are the models, the IPC models, modeling them correctly, accurately? Should He's making the case that we should be monitoring the sea ice melt with better like gauges
Oh
and
well, that's actually pretty good. We actually do pretty well. One of the few things we do pretty well.
but and then he says the IPCC rejects the AMOC shutdown within the much shorter time frame that this paper is claiming is going to occur unless we stop burning fossil fuels.
Okay,
Um,
let's broaden this conversation out because first of all, let's define what the IPCC is. The IPCC is essentially hand-picked scientists. It's literally the people, and it is all volunteer. So you don't, you volunteer to be a member of IPCC. So this isn't a global hierarchy. It's literally is, yeah, I'll do it because it doesn't pay. You got to devote your time and energy to it. You're it makes it harder for you to do papers. So there's a lot of reasons why people don't want to be members of the IPCC or don't want to volunteer. But there is prestige, and yes, there's also the scientific community. People want to be a part of it because they want to help. So it hurts your career, it helps your career. It hurts your career because you're not going to be able to spend as much time. It doesn't help your career. I'll take it back. It helps the planet. So people are just doing it out of love and respect. That's why they're members of IPCC or in the working committees. But there's no dogma there. It's different voices. They don't all agree with each other, and it's to say that to think of them as a group of people. Um, it's just this fellow scientific community. So if he's in the minority, it's not because anybody's against him. It's because his view is in a minority. And it's not that it's IPCC, it's the overwhelming majority of most of the scientists that I listen to, that I read, that I follow on a daily basis, do not agree with the aerosol conclusion. Is it there? Oh, yes, it is. There's no question about it. Is that we all agree that aerosols do have a significant change. But is it as big as he claims? I don't see the evidence for it. And to me, yes, we can get the evidence, but it's better to get the evidence and then make the claim than make the claim before you have the evidence. And that's why I have issues with the Hansen paper. Uh, and you also ask who's out there, cheerleading, who's out there saying, of the scientific community, who's out there saying, yes, he's right. And it's not many. It's definitely not my favorites, Rhodey and Housefather. You don't hear man is being very polite. There's obviously an argument between the two of them, and man has always said, he has a background and he has a history, and Hansen is quite frequently right. So he's his way of is it's like he's deflecting uh, any tensions. He doesn't agree with Hansen.
well,
And man is just one man.
I mean,
Sorry.
no, that's okay. And you, yeah, you make a lot of valid points. I'm just reading what the article says. And then another interesting fact that they talked about in the video, and I think it's probably also in this scientific article, is about the extra solar radiation that the Earth is absorbing. They say it's 1.5 watts per meter squared of solar energy. The additional, I guess it's a part of the Earth's energy imbalance.
Yes,
Um,
EEI.
but what this is equivalent to is quite mind-boggling. Um, he says it's equivalent to 35 times annual world energy use. This
Yeah.
additional solar energy that's coming in. Now, the
Now,
reasons
I,
behind
I
it.
don't. When did when did they put this paper to bed? I don't know because papers take a while. It's not the data doesn't. They don't do the data and then say, "All right, tomorrow we'll publish," and then do the release. But excuse me,
Mhm.
I have the latest data, and this is literally 2 days old, and that's now down to 1.37. So
Oh,
Yeah, that is that has
the solar
that has
radiation,
gone. Yeah,
but
the EEI, the
the
imbalance,
EEI. Okay. Well, another
has
implication of,
dropped sharply in the last year and a half. Yeah, in the last year and a half, that has dropped sharply.
I mean, this was just published on February the
Yeah, I know
3rd.
that's the problem. That is
Right.
the problem. It was published February 3rd, but when was it put to bed? Because this data is so fast, it's changing so rapidly that what people publish today, I don't want to say it's obsolete immediately, but that 1.5 is now 10% less. It's almost exactly 10% less.
Well, Hansen does mention in the video that I think he has been working on this paper for quite a while, and that the fact that it's finally finished, now he's going to write a book, or he's in the process of writing a book, which I can't wait to read, because he's had an amazing career, and his role within NASA and also at the congressional hearings would be fascinating to listen to. So yeah. The other point that the paper makes, which I find quite terrifying, um, maybe we could talk about, is the fact that they say the climate sensitivity, which is how much,
The biggest number out there.
okay. Do you want to explain it? They're in this article. They're saying climate sensitivity is, get ready for this, sit down, put your coffee down, 5 degrees C.
There's two different measurements for sensitivity. There is the short-term sensitivity, which is ECS, and the long-term, which is ESS. And I have, of all the data that I have ever seen, high fidelity data, which is, I've got like 3,000 years of what high fidelity means literally every single year, or no more than every 5 years. And that's a lot lower. And even if I look at the last 50 years, I still get a lot lower than that. So he is Manabe and Wetherall's paper, which came out, oh God, in 1967, and then the second paper came out in 1973, said 2.4. Uh, that's a Nobel Prize winning paper. And I'm not saying that it has to be absolutely 100% correct. I'm not saying that it's definitely 2.4. But the data over the last century is telling us 2.4 is pretty good. Hansen, back in 1981, said it's 2.8 with a 6 year delay. So, uh, what changed? I don't know. Do we know what SO2 delivery? Oh, actually, I might have that somewhere. Do we know what SO2 delivery was during that time frame? Did SO2 change so dramatically over the last uh, half century that allows us to see that there was a uh, sulfur oxide emissions by world region? I've never even published this. Yes, I know I have everything. I've told people this in the past. And it is important to realize that if you see me do 10 charts a week, put out 10 charts a week, that's because I did 30 charts that week, and 20 of them just didn't go anywhere, or I have them in the in the back waiting because there's just so little availability. But the amount of sulfur dioxide in 1940, we were releasing about 52 million tons a year of sulfur dioxide. How do we know this? Is because we know how much oil we released, we know how much coal we burned, and we know roughly the quality of that coal and the quality of that oil, so we can calculate roughly how much we released. In 1971, we had almost 79, sorry. We went from 52 all the way up to 141 million tons. And that was when we breached. It was a little bit lumpy, but right now we are just about, let's for argument's sake say half as much as we did in 1979. So we have reduced our emissions dramatically since then. But the emissions are still higher than 1940. So if we look at a baseline, if SO2 hasn't changed that much over time, and we would have to do a histogram, and we need to know what's the life expectancy of a sulfur dioxide molecule in the air. Does it last 1 year? Does it last 12 years? Does it last 20 years? And we don't have this information precisely because it's a harder molecule to study because again because it's heavy and because we didn't have satellites in the sky looking specifically at SO2. So it's very hard to say how the negative forcing has changed over time. It's really difficult. We need more data. I cannot buy five. I have a hard time buying four. It's oh, and by the way, now let's go to the second half. Um, Earth system stability. The papers that were written in the last 5 years seem to indicate that that is somewhere between 7 and 10. But that's because a lot of stuff happens. Uh, let's just say that, for argument's sake, let's call it five. Every year, a little bit more of the ice will melt. Every year, a little bit more of we'll have more cloud cover. But that's a very slow and gradual process, and that also works with a tiny sliver of the Milankovitch cycles. So all of this information uh, is only looking at a very tiny slice of all of the possible parameters coming in. 1,000 years later, the parameters change. 10,000 years later, the parameters change more. 100,000 years later, they have even more change. But over time, those changes smooth out. So that's why the long-term stability is so much higher than the short-term stability, because the long-term stability incorporates all of the potential glaciation and deglaciation cycles. Because right now you're in the middle of the hurricane eye. You're only seeing little changes. So if you have whatever the short term is, you can comfortably say double it, if not more, for the long term. And again, depending on the paper, we have long term as anywhere from 7 to 10. So yeah, he's saying 5 years, five for short, 5.4 for short term. Oof, that's hard to imagine. And is that just during the current realm? And what I mean by the current realm is we're in an ice age. We are still in an ice age. We have a North Pole ice cap. We have a South Pole ice cap. We have glaciers. Not quite everywhere. We only have one glacier left in Africa. I think we, I think we're finished with most of the United Kingdom glaciers. There's like one or two left, and they're like uh, this the size of a small farm. There used to be like 3,000 glaciers in the United Kingdom. Now there's a handful. Obviously, there's a lot of glaciers in Europe and the Central Europe. The Alpine regions are and the Nordic regions are all glaciers. So it's really hard to tell. I wish we had more solidity on that. I'm sorry, I had you speechless here. Uh, but the problem with any and all of these papers is they're a new piece of information that has to be adjudicated in comparison to with all of the old pieces of paper. And again, that doesn't mean it's wrong. It doesn't mean that Hanson's wrong. It doesn't mean that Bova was wrong. It doesn't mean that Osmond was wrong. It doesn't mean that uh, West West Westerhold or what's the other one? There's a paper that was the Ray is the sister paper to Westerholt. It doesn't mean any of these are wrong, but it just means that this is not so much contradictory, but is an outlier. It goes against the trend. So it's I'm not going to say straight out that what Hanson's saying is wrong. I'm going to say that it contradicts a lot of what we are seeing in the other papers. Are you still there?
I'm still here.
Good, because I was afraid for a
Yeah,
minute.
thank you
Uh,
for that explanation. Actually, one more thing. I was just looking at this, and this is in the part of the article, point of no return. Um, he talks about climate feedbacks are real. Paleoclimate evidence shows that fast feedbacks such as water vapor, clouds, and sea ice amplify climate sensitivity from 1.2 C degrees Celsius for double CO2 with no feedbacks to as much as 4 to 5 degrees Celsius. Um, these well known feedbacks more than triple the equilibrium climate response. However, equilibrium climate response is slowed by the ocean's thermal inertia. And then he gives an example that the warming from 2020 reduction of ship aerosols is 1/3 complete after 5 years. The next third requires a century, and the final third requires millennia. Does this mean that we still have an opportunity by removing, carbon or lowering our emissions, or by reforesting and things like that, to to slow the warming or to stop the warming because of this type of inertia? So, because
uh,
maybe the
th
additional warming will
there's
never occur if we reduce the net
there's
like climate forcings.
there's a reason why we have so many different climate pathways. If you look at all of the papers that have come out, we have so many different emission pathways. It's because we don't know what human behavior is going to be like. So because we don't know what our response is going to be to all of this, we have very wide-ranging potential the parameters of what future climate may look like. So yes, it's possible that the economics of, and it will, I think, the economics of wind and solar and geothermal will just completely overwhelm the economics of fossil fuels, and fossil fuels will slowly uh, be um, eliminated from most climate systems simply because they're too expensive. I haven't looked at the newest papers. I saw somebody mention it that uh, in Australian dollars, the G7 is now two. I want to see what is that, like 1.4 to the dollar. That one it's $2 trillion a year for the G7 in subsidies for fossil fuels, and that's a breathtaking amount of money. So maybe people are going to get together, and countries are going to say, yeah, it's time that we stop subsidizing fossil fuels, that we let the free market uh, take take place. For all I know, it's Pup's company. I'm still trying to identify where the hell that company is. But there's a company on the Hudson River, not too far away from me, that is making a small nuclear reactors. And in
Oh
their
dear.
brochure, they showed a photograph of it. And I'm looking at the other side of the Hudson, at the New Jersey side, and I'm trying to figure out, based on the distance and where exactly this company is, because they just say Westchester County. So I know it's within 20 miles away from here, and I pretty much have it pinpointed to like a 7 or 8 mile direct area. It's probably somewhere between Ossining, New York, and because Ossining in New York, it widens, and the Hudson becomes a little more corrugated. And not Tarrytown, the city that's right after Tarrytown, Golden's Bridge. So I know that there's a small company building a nuclear reactor. Uh, if something goes wrong, I'll be the first one to tell you. I'll hear the boom.
Well, I and this is getting on to our other topic, but there is a huge problem with nuclear waste disposal in the United States and around the world. There's only one facility that safely stores it. Apparently, many different places across the United States are nuclear waste disposal areas. But yeah, so there's that problem, I guess, that we
Isn't
should
it?
discuss, and that
Isn't it?
that links us. What?
Yeah, isn't it absolutely amazing how much of the problems we have are, oh, that's going to be for future me to solve. How many
Very
of the
true.
problems we have in our society are companies and industries and even people saying, yeah, we'll solve that later. Let's just go forward now. We'll we'll deal with the consequences in the future.
Are you saying we procrastinate?
Yeah, it's cost of doing business. The cost of doing business is the problem with having trying to get to be as profitable as possible without caring about the externalities. And if you're not going to deal with the externalities in a timely manner, they can build. So that is, I think, the biggest issue is that we let those externalities build, and we didn't face them when the time was, ripe to discuss them. And now we're dealing with them in a real time basis. And the thing about, oh God, I love how people always tell me, why don't we just get Elon Musk to take the nuclear waste and launch it into the sun? Do you know how expensive it is to throw a pound of material into the sun? It's a lot more expensive than it is to throw a pound of material into Mars. So why don't we just simply launch it into Mars? Although that would really screw up his plans, wouldn't it? Take all the nuclear waste and throw it on Mars, or pick any one of the Trojan objects. There's two sets of asteroids that are roughly in Earth orbit, but away from us. Because you get this amazing situation where the Earth and the Sun create holes where the gravity is just right, and things go into those holes and pretty much stay there. So right now we have satellites at L1, which is one of those. There's five different holes. They're behind the Earth, in front of the Earth, to the left of the Earth, to the right of the Earth, to the up and to the down. So yeah, why don't we just launch into let's say launch something into L5? That would be a lot cheaper than launching it into the sun. Sun is ungodly expensive to launch into. In fact, we have the in order to get to the sun, the Parker satellite mission is the absolute fastest it's the absolute fastest anything human beings have ever created. And the speed, I don't have it here, but the speed of Parker is like a half a million kilometers an hour. It's ungodly fast because that's what you have to do to 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 get to reduce. You have to reduce speed to get to a lower orbit. You increase speed to go to a higher orbit. You reduce speed to get to a lower orbit. And we had to reduce the speed so much for Parker that it is now traveling that fast with relationship to the Earth. But anyway, I guess it's time to go to the headline topic. It's not going to be that long, but it's going to be here, and that is the amount of power that we are spending currently uh, streaming, data storage, data transmission. Bitcoin, especially, or not just necessarily Bitcoin, but all of the blockchain transactions. And let's just do a brief, introduction to the whole concept of the blockchain. It's to distribute information as broadly as possible to as many places as possible, but randomly as possible, so that information can be spread into a million different places and nobody knows where it is except for the information itself knows where it is. So the information literally sends itself into hundreds of different places and it knows where it is. So it can communicate with itself and then put that information back into individual discrete servers. And this is the blockchain, which, 5 years ago, blockchain was AI. What I mean by that is everybody was spending all of their money. They were Companies were just calling themselves blockchain. What did they do? They did nothing at all, but they would put the word blockchain in their name, and suddenly everybody would like, oh, we have to invest in this company that makes cars or something, or makes a detergent. And it had absolutely nothing to do with it, but just the fact that they used that name attracted uh, investors. So go back 5 years ago, the blockchain was the AI of today. Everybody was spending money doing blockchain work. The problem is, and the purpose of blockchain is to make intrusion impossible. It's to make theft impossible because the system has so many, literally infinite number of potential locations and positions and where the data is and what the data is doing. It is virtually impossible to hack. It's not like the other techniques we have of data protection, where if you have the right computer, a quantum computer, and it's with the right size of number of qubits, where you may be able to solve it in a few hours. This is the best quantum computer couldn't solve the blockchain in a few years. And even if we increase the abilities, and even if we use AI, which wouldn't work actually, to increase the abilities of quantum computing, you still couldn't do it in a real-time basis that would make it useful. But what all of this does, to have so much data being shared back and forth, and to have all of this data being transmitted in tiny little pieces to randomized areas, is astronomical. I have the data. Let me put it up. I should have turned this into a graphic. So instead of putting this on a graphic, I'm just going to give the latest information. But one Bitcoin transaction, one transaction takes the equivalent of 1.2, and I'm rounding down, megawatt hours of power. 1.2 megawatt hours of power is about uh, 40,000 households for a day. So if you go, for some reason, you want to buy a bit of a piece of chewing gum with a Bitcoin, that chewing gum transaction is going to be the equivalent of, at 1.2 megawatt hours, with kilowatt hours for nowadays, for let's say about 20 cents to 25 cents. So it's about $200 worth of electricity to buy that $1 stick of gum. The amount of energy being used by, and we're not talking even mining Bitcoins. And by the way, here's a great idea to figure out how much it costs to mine a Bitcoin. And that is, what's the price of a Bitcoin? If Bitcoins are $100,000, that means that the retail price of the energy needed to create to make a Bitcoin is $100,000. Now, of course, there are people who, because they can get their energy a lot cheaper, right, Pup, who are able to do Bitcoin mining. It's uh, Bitcoin mining for them is successful because they have energy, so to speak, to burn. But if you're not one of the people that has energy to burn, the amount of energy used to consume a Bitcoin, to create a Bitcoin is absolutely insane. Uh, to give an example, right now we're looking at the annual energy consumption of the Bitcoin universe is roughly that of Poland or Egypt. So we're talking about, medium-sized. Uh, well, Egypt isn't exactly. They're still a developing nation, but Poland is, yeah, a first world nation, and it is a major. It's not quite G20, but it's close to being G20, and that's how much energy is being used to maintain and to establish and to run the Bitcoin universe, and that is frightening. How much power we are using to essentially just do nothing. How much does it cost for a Visa transaction? Yeah, I've mentioned how it was 1.2 megawatts for a one single Bitcoin transaction. It's about 1.5 megawatts for 1 million Visa transactions or MasterCard or any credit card transaction. So you could do essentially about 1 million, a little less than 1 million credit card transactions. And that is essentially the same thing. You put your credit card in, your credit card company looks at your credit card account and it says, okay, we are now going to charge X number of euros, dollars, pounds to this person, and we are going to transfer that to this company, this person's bank account. So you can do roughly 1 million credit card transactions for the same amount of energy of a single Bitcoin transaction. Pup, how you doing?
Yeah. First off, to mine a Bitcoin, it's about 130,000, uh, and that's why you have to buy your electricity at sub 6 cents a kilowatt hour. Um,
Yeah.
the the cost of transferring, um, I I just did a small transfer. $43 with the Bitcoin cost, the gas, as they call it. The cost of transfer was about 30 some cents. So at retail, you're looking at 15 cents a kilowatt hour. That's what I'm paying. So you're looking at about 2 kilowatts, not a megawatt.
Every source that I've been reading, and I've looked at several, and the 1.2 megawatt hour per transaction is about a median. Some
Yeah,
are 1.5, some are saying about less than one, like 700,000.
yeah. Now, what they're not including, or that makes that a misleading number, is uh, when you're mining Bitcoin, what you're doing is you're consuming energy to verify transactions that haven't posted to the blockchain yet. Okay? That's what mining is. You're trying to solve, as miners say, you're trying to solve a block. Um, so really, and when you do solve a block, then you are rewarded currently 3.125 Bitcoin. So the two are really kind of intermeshed there. See what I mean? Because a
Okay, so
block,
you're saying that each time you solve a fractionate amount, you're doing a fractionate transfer. So it's a
well,
fractionate transaction.
yeah, there could be literally thousands or maybe even hundreds of thousands of transactions inside that the solving of one block. Okay, so
Um, I'll assume I understand what you said because I was only out for like 7 or 8 seconds. But I guess yeah, that was kick out number two.
yeah, and understand that a block gets solved every 10 minutes. Period. End of a line. It doesn't matter how many transactions are in a block. It's one block gets solved roughly every 10 minutes. So there might be, one transaction in there, and there might be, a million transactions in that block. See what I mean?
It depends on the speed of each of the servers that are trying to solve the problem.
Nope. Nope.
No?
No. It's the variable in the equation is the number of transfers in a given period of time. A
Wouldn't
block
that
is the way the Bitcoin network is set up is every 10 minutes it solves somebody somewhere solves a block, and there may be an unknown. Well, it's known obviously, but there is no standard number of transactions in a block. Okay.
I'm trying to figure. No, I understand what you're saying. I'm trying to figure out the rationality behind having a variable number of transactions per solve as opposed to a singular or a set number or I think
It's
binary. You know,
it's so that
10 to
no
the 2, 10 to the 12, a 2 to the 12, 2 to the 14, whatever.
Yeah, the reason is that's so that you know that if you make a transaction, it will be accredited and included in the blockchain in no more than 10 minutes. That's why. Because otherwise, you would get into a situation where there was one transaction in it and no miner wanted to solve that block. See what I mean? Because it wouldn't be worth anything. And that's why
So, so each block has a variable capacity for the number of uh, mathematical equations necessary to solve.
no.
Gigaflops.
A Bitcoin transaction can be 1 millionth of a Bitcoin. Okay, so let's say I had a Bitcoin and I wanted to send 1 millionth of it to a million people. That would be a million transactions in certainly at least in one block. And if two people did that, then there would be 2 million transactions in that block. Or it could be, I'm going to send Sal 1 Bitcoin, and now there's one transaction in that block. It's a timing thing. It's so that nobody waits too long to have their transaction accredited globally.
Okay, so you have a fixed clock speed. Wow. Okay, in economics, this would be known as a clearinghouse. So you
Yeah.
do a clearinghouse every 10 minutes.
Yes. Yes.
Well, that makes sense. It's we
And
just
some
changed the regulations in the United States. In the United States, we had a 3-day clearinghouse. So if I bought a share of stock from you, technically it would take 3 days between the money would go from me to you and the share would go from you to me.
correct.
And like a little more than a year ago, we changed that to an overnight clearinghouse.
Yep.
And if you think about it, it's like, why the hell does it take so long? But that's the way it was. It used to be a 1 week clearinghouse.
I remember when wires could take, and if you send a wire even today
Yeah.
to China, it's at a minimum 2 weeks.
And
And I
part of
know
this, by the way,
and I
and
know
part
that
of this, by the
because
way, again, I'm sorry.
I know that because I used to pay for my Bitcoin miners only did it once by wire transfer, and I made the damn order, and it was literally 3 weeks later I got a confirmation. Hey, we got your money. We're shipping them, and that was the last time that I ever bought miners and paid for them with fiat currency. Paid for them with Bitcoin. I'd make I would place the order, go make a cup of coffee and come back and By the time I was done, I got my order confirmation and a ship date.
I'm trying to do something here. I was because I'm trying to. I should have done this earlier, and I apologize for not doing it. But part of this conversation is a lot more than we have crypto actually on the back end of this because some of the other, if you look at what we're talking about, streaming AI and crypto.
Yeah, crypto
I was
chews up a
looking at.
shit pot.
I was, but the next, of course, is okay, we're going backwards. Is AI and the amount of
Oh,
energy that is used to do even like one uh, generative AI drawing is extraordinary. Or the amount of energy to answer one AI query is breathtaking.
it's huge.
And
Oh, it's I have a stat on that. If you generate 1,000 images with AI, it emits as much CO2 as driving 10 kilometers in a gas-powered car.
I think that estimate
that's
is
less than
low.
I thought.
I think that estimate is
Well,
dramatically low.
here's another one. I've got another one. The large language model Bloom emits greenhouse gases equivalent to 19 kilograms of CO2 per day of use, which is roughly the amount generated by driving 49 miles in an average gas-powered car.
I still think
What
I
else?
still think that's low.
Do you still think it's
Yeah,
low?
like
Well, the problem, this is one of the problems too, Pup, is that the big tech companies aren't telling us how much energy that their AI models use. So these are best
yeah,
estimates.
and understand that many of the large data centers that host and do AI, which is virtually all of them, a lot of those are what they call behind the meter. This is exactly what, for instance, Microsoft's trying to do with 3 Mile Island. Is
Are these, sorry, is this the hyperscales? Is that what they're called?
yes,
Or hyperscaling?
yes.
Yeah, okay.
Um,
Please explain.
And by the way, and oh, I'm, I'm sorry.
okay, so one thing at a time here. What Microsoft is trying to do is they bought you, I believe it's Unit 3 at 3 Mile Island, which had been shut down. For since like the 1970s. Remember 3 Mile Island, guys? Um, and
Right,
they
Pennsylvania.
and they want to refurb it and then operate that so they can power a data center, right? Amazon's doing the same thing there, but instead of that's down in Georgia. Um, so that way they don't. They're buying power at literally pennies on the dollar versus like if you plug in a toaster at your house, you're paying probably 15 cents a kilowatt hour to run the toaster. So a lot of those, what I'm trying to say here is a lot of those calculations are based off of if they bought power, it would cost blah. But like Bitcoin mining, a lot of the Bitcoin mining farms now are connected to solar, large solar arrays, because solar's the cheapest way to generate power. I mean, I know of one Bitcoin mining farm down in Texas, for instance, that put up it's just under a gigawatt of solar exclusively to mine Bitcoin, and they sell whatever is left over, which is probably in the tens of kilowatts. Realistically, they sell that back into the grid at 2 to 4 cents a kilowatt hour. Um, so these numbers are extremely there's a lot of error in there. Let's put it that way.
And,
I
and I wanted to, I'm sorry, and I wanted to quickly add that not only are they using energy to create all of these, but now they have to use energy to turn on their air conditioners to cool these circuits to prevent them from going nuclear.
Yeah, yeah, and that power is in the case of a solar run Bitcoin farm. You're probably only using about 80% of the power to actually do the mining, and the other 20% is
Yeah.
the cooling of the farm.
And it builds, and of course that changes. And there are times of the year where you might actually be able to, farm that heat energy out. I would imagine that this would be a lovely time of year if you did a cogeneration system where you would have, a steam generator and you could, use your computers to generate the steam that you could then sell to other people.
Yeah, the problem, Sal, is most of these farms are located
Yeah, they're too
so
far away.
yeah, that it's not feasible. Again, I turned on two Bitcoin miners this winter to heat my house. Not exclusively, but to make up. We got a cold snap, and my regular heating system didn't cut it. My pellet stove died, and I had to keep the house warm, so I turned on a couple of Bitcoin miners. And the reason I did that, even though I'm not going to make any money off the mining because I'm paying too much per kilowatt hour, 15.6 to be precise, is that I get the heat and then I get a rebate effectively by selling the Bitcoin that the two machines mined.
And yeah, that
Oh,
is it is funny how in your case that heat is not a externality; it is a valued. It's a commodity, not an externality.
Yeah, it kept my pipes from freezing in my back room. Quite
well,
literally.
that's good to hear you're not cold.
Well, one of the miners was where the pipe comes up out of the ground from my well. That's why I had one of the Bitcoin miners, because that pipe, as it exits, if I don't heat that room, eventually the ground freezes and creates an ice blockage, and I don't have water.
Right, and you don't want to shut off the pipes. I always shut off my outdoor one, but definitely want to have the ones in the house working,
Yeah,
right?
it's nice to take a shower and make coffee. Um,
Yeah, exactly. Wash dishes.
yeah, water the dog, the cat, etc., etc. Um, but most of the time, and by the way, because of the current parameters of the Bitcoin blockchain and market and mining, most of the Bitcoin mined is not by the little guy anymore. I would even at my peak of mining a number of years ago, I wouldn't have considered myself a big guy. At best, I was one of the largest small guys. Um, and now, I mean, most of the mining farms out there, they'll put 200 miners in a 20-foot sea container, and each one of those miners will pull 3,400 watts. In other words, each 20-foot sea container is, round numbers with air conditioning, probably pulling a solid megawatt. And you
Well,
look at,
this is kind of like, yeah, this is the economics of scale.
yeah, yeah, but they're also located. Well, a good example is I was in the middle of negotiations with one of the Native American tribes out in Washington State, and because they have solar and wind, and they were having problems selling their power back into the grid at anything more than 3 cents a kilowatt hour. And I called them up and said, "Hey, I'll pay you 4." And They were in the throes. They were willing to pour the concrete pad, run the run the pay for the transformer to go from 115 kV down to uh, uh, 480 volt, and I mean, they were ready to do all the infrastructure for me, basically, where all I would have had to done is just buy 200 miners, put them in a container with some racking and switch and probably a monitoring laptop, and then truck it out to them. Anyway.
I, let me help the audience out here. Essentially, what he is saying is because of the way we have centralized energy systems, individual energy suppliers cannot get their energy put to market. So it is almost a situation where they are grateful to be able to have someone privately buy their energy at a considerably higher rate than they would get, but at a considerably lower rate than anyone would get in the marketplace.
Yeah,
And
yeah.
this
Right.
the
Do
problem
you
is,
think?
yeah, this is the problem is the economics of energy is still too close to being a monopoly.
Yep.
Right. And I think having these tech companies buying into it and having energy privately also raises a lot of concerns about control over energy.
Well, and that's exactly why both Amazon and Microsoft are having problems, because a lot of the money they got turned down by I believe it was Misa, um, because a lot of the money to build Unit 3 was from the federal government, and part of the charter was is that energy was supposed to be used for the general public, and now Microsoft wants to come in and refurb it and then basically eat all the energy that that reactor makes, and that violates public trust.
That definitely does. Actually, one of the articles I was reading about, how the future AI and data centers will be powered, looks at nuclear, um, and raises a lot of questions about how many nuclear waste sites still haven't been cleaned up from like the 60s, 70s, and 80s, including 3 Mile Island. The storage and containment of nuclear fuel is a huge problem. Right now in the United States, there are 90,000 tons of nuclear waste stored at 77 sites in 35 states. And this waste increases by about 2,000 tons per year. These small modular reactors are only going to add to this problem. There was a small modular reactor that it took many years to get safety certified, and then I think it was called the New Scale SMR. In 2023, they abandoned it because the construction costs of it doubled to 93 billion. So I think
Yeah,
related,
yeah,
sorry, related to
they went.
this,
Sorry, very quickly. They went literally from like, oh, yeah, these guys are the guys who are the leaders in the industry to they're fighting against bankruptcy.
Yeah,
right.
and the New Scale project was heavily backed by Gates, by the by. Um, yeah, that, but and oh God, I didn't like their design to begin with, but that's another story. Um, where the future really is going in uh, uh, is not SMRs, but micro reactors that are Triso pellet based Triso pellet pebble bed reactors. Those uh, uh, God, I could go into the next 3 hours about what a Triso pellet is, but the bottom line is they're built in the factory. They're small. They literally fit in a 40-foot sea container. And there's several companies that are doing this with slightly variant designs. But what a Triso pellet is it's a ceramic pellet that has the enriched uranium in small particulate inside the pellet. Um, and the pellet is specifically designed such that when its useful life is over, it can be crushed. The useful fissionable U-235 in it can be extracted and then inserted into a new pellet. In other words, what I'm trying to say is they won't have the waste problem. And a good example of stored waste is about every 7 years, they uh, uh, they try to re-permit, and they've been successful so far, by the by, the reactor at Prairie Island, which, by the way, sits on a native reservation, ironically enough. Um, and what they're permitting is not the reactor. They're asking for a permit to expand their used rod storage, or used pellet storage. They store them in rods, um, but they replace the rods in those things every 18 months. A percentage, 30% of the rods every 18 months, and that's
I
huge.
think a lot of the problem is that the traditional classical nuclear reactor was based on 1940s, 1950s technology, and the fuel rods had to be large and massive because you didn't have the same level of capability we have today of microcontrolling each and every it was either literally was almost all or nothing. You either had a dropped rod or you had a shielded rod.
Yeah. Now the problem
And we don't have to do that anymore.
I'm gonna lay the blame on the manufacturers of the reactors, and that would be GE and Westinghouse, in that they specifically have provided no means at all, and not even to third-party companies, to reprocess or recycle. Um, well, I'm sitting here charging the car, and the guy just came by with a bobcat with a huge ass leaf blower on it. Anyway, that it was blowing the snow off the brand new cars. Um, but the problem here is a greed problem. So they build every single reactor is a one-off. The cores aren't, but all the rest of it is plumbing, blah 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 blah. So what happens is that you build one of these conventional single loop graphite reactors, and you have to go back to either GE or Westinghouse to buy your fuel. And remember that you're replacing 30% of the fuel rods every 18 months. And there is no way, no provision to recycle the pellets that are inside a fuel rod. So the only thing the owner of the reactor can do is store them. And there is no universal place in America to store spent fuel rods. So they have to be
And,
stored on site. It's a
and
greed
rods are
thing.
proprietary.
Yep.
And
Yep.
rods are proprietary, which means you're locked into a perpetual contract.
This is why back in the 70s, GE and Westinghouse would build a reactor basically for free and give it to you, because they knew that for the next 60 years, they'd have an addicted client. It's just like a drug dealer. The first couple of hits of heroin are free, and after that, you're addicted. And, you know, and it's the same thing in nuclear power generation today.
Yeah, every technology, the delivery of the product and the delivery of the maintenance are always one and the same. It's like
Yep.
with any car. You buy a car, they'll make $1,000 profit on selling it to you. Oh, by the way, if you sell that car back to them, they'll make 5,000 profit selling it as a used car.
Yep.
And then every year they're relying on $1,000, $2,000 of maintenance that you're going to pay every year. So they're not getting you on the car; they're getting you on the maintenance, and they're getting you on when you hopefully sell it back to them, and they can sell it as a used car. The economics of energy is the same as the economics of a car industry or a smartphone where you buy a phone for $1,000 and then they get you for $200 a month for the next 5 years.
Yep. And by the way, in electric vehicles, there's a new scam going on, and I'm participating in it right now. So I bought my Chevy Equinox EV. I'm sitting in St. Cloud because I'm about to go ride sharing, and the one of the cheapest places to charge that car is at Gillian Chevrolet. I'm sitting in their parking lot right now, which is why I just had that Bobcat come by and make a lot of noise, blowing the snow off of new cars. Um, so I'm paying them 45 cents a kilowatt hour to charge my electric vehicle.
How
In
much is that?
addition,
But yeah, I know, and you have and you're generating power not quite for free, but on the other hand, you don't have a 100-mile long extension cord.
121 mile, 29-mile
Okay.
extension cord. If you want to put it right down to the
To be
pennies.
exact. Pop, so how much will it end up costing you, and how long does it take to charge it, if you don't mind me asking?
Well, that depends on which pedestal I plug into it, Gillian Chev.
Uh,
Um, when I tried to plug into the 120 kilowatt hour pedestal, they had a Chevy Sierra that was sucking up all the fucking power, and mine wouldn't charge. So I'm now sitting at their pedestal that is at a 50 kilowatt charge rate. It is currently a car is currently accepting 27 kilowatt, and it's going to take an hour and change to go from 27% to 100.
uh, uh, what is
If
your
you've got time to have some lunch and drink some coffee.
Well, that's why I'm sitting in a room with you guys.
at what point do you start to throttle back? 80, 85?
The car automatically starts to throttle
Yeah.
back at around 83%.
So right between 80 and 85. Okay.
Yeah.
Oh,
Now,
let me
because
quickly sorry, let me just quickly tell everybody what that means. You want to slow down the rate of charge once you reach roughly 80 to 85% because you want to reduce the amount of heat in the battery. By throttling back the charging rate, you're going to help the car last longer, or rather help the battery last longer.
yeah, you're not going to develop dendrites between the anode and the cathode, which effectively shorts out a cell. But what I was going to say is because I'm plugged into this slow ass fucking DC charger, um, it will throttle back from 27 to about 15 kilowatt. So kind of
What's
annoying.
your battery?
85
70
kilowatt
something?
hour.
What's 85? Okay, so you're 85 kW. So if you were to do the whole thing, it would be about a little less than $40.
Yeah,
So how many
today,
miles can you do on $40?
well, it isn't 40. The most I've ever spent going from
I'm just saying.
17% to 100% is $26 and change. And I get 320 miles of the range out of that on a perfect day when the ambient air temperature is 70 something.
So
It's
the reason
9
why
degrees.
I'm sorry, the reason why, and I'm only going to mention the United States here, but you're essentially paying uh, for roughly 300 miles of range. You're paying roughly, let's call it a little more than 6 gallons worth of gas. And
Correct.
there aren't many vehicles out there that can do 300 miles of range on 6 gallons of gas, or
That's
even
correct.
close to that.
That's correct.
So even though you're paying usurious GM gas electricity rates, it is still dramatically cheaper than if you were doing a gasoline powered car.
Which is why I bought the EV and use it for ride sharing.
Oh yeah, if you're doing for people in the audience who are not familiar with that term, it's Uber, Lyft is ride sharing. So because you're spending maybe 40% as much as a typical Uber would or Lyft would for a gallon of gas. Your profit margin compared to them goes through the roof because
Yep.
your
And
maintenance schedule, also your maintenance schedule is much, you're not doing oil changes.
I'm not doing shit. Now, my rate of pay for under Lyft for ride sharing is $1.74 under Minnesota law, by the way, is $1.74 per mile plus 31 cents a minute.
So you're getting because your costs are so much cheaper than everybody else in your local area. You're able to operate at a much higher profit than everybody
Yep.
else because you're running an EV as opposed to running a gasoline powered vehicle.
Yep. Now, there's a
That's what
caveat.
I'm just helping everybody else understand what you're saying.
Yeah. Now, there's a caveat in there. When the temperature, it's current temperature, the car's telling me it's
Yeah,
9 degrees. So guess what, folks? I'm not going to get 320 miles out of a charge. I'll probably get in the middle 200s. So that reduces um, my profitability, but it's still better than driving a gas car.
do you have it? I'm guessing you don't have heat pumps in the battery.
Yeah, they do.
Oh, so
Yeah,
and you're still that low?
yeah. I lose about at least when the temp's this low, 9 degrees. I lose at least 14 to 17% in range
That's not so bad.
because it's well, yeah, it's certainly better than the Bolt, which lost 30 to 40% when it got this cold. Um, but that's because it was a nickel manganese cobalt battery, and this is a lithium iron phosphate battery, and they use a heat pump versus resistive element heating to keep the battery warm.
I didn't know GM was that advanced that they were using the lithium ion phosphates on their on their top line vehicles now. Whoa,
Yes,
no wonder why they're selling.
yeah,
No wonder why they're selling to Honda.
yeah, of course. Um, Now, that's the GM Ultium platform. It's their what they call a skateboard platform. It's what the Equinox and the Blazer are built on.
I remember the original skateboard was like 1994, 1995.
Yep.
People don't. People may not understand that as crazy as General Motors has been one of the world's leaders in technology for the last, well, since World War II. It's not we don't really think of GM as being such a technologically advanced company uh, because they have lousy marketing and because they don't get the press out. But for those of us in the engineering community who know this stuff, GM has always been, they just can't build good cars, but they've always been at the absolute top of the technological food chain. They
Yeah,
just
and
need better marketing.
yeah, and by the
Well,
way, I will probably trade in this 2024 either in late 2026 or early 2027 because the beginning at for end of first quarter in 2023, I had to remember what year we're in. They licensed Samsung's high density lithium iron phosphate battery tech, are just about completing building the plant in Ohio. And if you put those batteries in this car, I would probably get around 600 miles worth of range.
I was thinking 600. Yeah, that's exactly what I was thinking was going to be. Uh,
Pup,
we're
do
still
you have
fighting a lot of. I'm sorry, go
oh,
ahead.
that's okay. I just wanted to ask Pup a question. Well, I'm interested in getting an electric vehicle, but I haven't basically gotten off my butt to find one. But there is an interesting place now. We have a used electric vehicle place called Shift Electric Vehicles. which sells used electric vehicles. So do you know of any that are in Minnesota, or is this? I'm assuming more of them will open up as time goes by because people will want to get rid of their old electric vehicles.
I would not buy a used electric vehicle.
It depends.
No?
Because you have no idea how the previous owner either treated the battery. They like I'm doing, because I'm going to trade this in 2 years. I am abusing the battery in this motherfucker. I am regularly charge it up to 100%, and that is bad for the battery. Um, but that's not going to be my problem, because in 2 years it's going to become probably Gillian Chevrolet's problem.
Mhm.
Now the reason I'm willing to take that risk and abuse the battery is because GM has a really good warranty on the powertrain, which includes the battery. It's 100,000 or 8 years. Um, and even at the accelerated mileage that I'm going to put on this car, I won't hit that 100K in 2 years. And when I turn this poor thing in, it is literally going to need a battery replacement.
See, what I've been
Okay,
looking
well, that's good.
what I've been looking at is a possible 1 or 2 year old, either a Volvo C90 or C40 or XC40, or even a Polestar 2, and you can get them with 1 year used with maybe 5 to 10,000 miles on them for about 60% of list. So if the car was $55,000 when it came off the assembly line, you can get them for about 37, 38. So you can knock almost $20,000 off the price of a car that barely has been used, because so many of them are on program, and a lot of them were also used as loaner cars. Harold, hello.
Yeah, no. So, and I'll be,
Oh, sorry.
no, it's okay. This car I'm sitting in has got every gets gadget you can order. Full hands-free driving, auto parallel parking, blah 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 blah. Um, the list price in the car was 53. Because I bought it in November, that particular dealer, it happened to be Friendly Chevrolet. What a corny goddamn name. Um, but they had a ton of 2025s coming in, because they were the dealership in Minnesota that took the majority of allocations from other dealers that didn't want to sell electric cars. Okay. Well, they've got all these 2025s coming in. So guess what? The 2024 is sitting on the lot.
Yeah.
Literally in a month, we're going to be last year's model. And they knocked 8,000 off the MSRP. Then I took the $7,500 clean vehicle rebate. Then, because I was trading in a Chevy Bolt, took another $2,500 as a GM loyalty rebate. And then, because I'm a veteran, they gave me another 1,000 off from GM. I took $19,000 off the price of a $53,000 car. I financed 37.4 with no money down. And that's why I'm
It is
sitting in this
amazing.
thing.
Yeah, it is amazing how, because companies really do want to sell these vehicles, they are willing to incentivize them to the gills, and take advantage of that when you can.
Now,
Okay.
the same dealership, they weren't willing to move an inch on the price on a 2025. Not an inch. I still would have gotten the 11,000 for the clean vehicle. And by the
Yeah.
way, part of the reason that I decided to pull the trigger in November was because fucking Trump got elected. You know, and I
This reminds me of the.
Oh, but interestingly enough, he hasn't pulled the funding, the rebates on the EVs. I wonder why.
well, I think he will. I think he
Oh,
will.
I think he has it because of you know who.
Well, Elon.
Oh, that's a different story, because Elon isn't a part of all of the programs that are out there, because his
Well,
batteries are not always US.
Oh, really? Okay, I didn't know
yeah,
that.
the new Model Y. They're calling the Concordia or some such bullshit. Um, Beginning of last year at the Beijing Auto Show, Cattle released their new high density batteries, and a week later, Elon was there negotiating with the CEO and China to build those the new Model Ys in fucking China, and then ship them in. And those Model Ys are not eligible for the $7,500 rebate because the battery
You know what?
because the battery ain't made in
You know
America.
what? You know what also isn't eligible for American ownership? Deep Seek. A new law would make it illegal. And if it goes through, punishable with 20 years prison time.
Well,
I'm not kidding.
well, then I won't tell anybody that I downloaded their large 671 billion parameter model.
You did?
Yeah.
Oh, tell it. Have you, is it on your phone?
No, it won't fit on my phone.
Okay, because I heard that on the very advanced phones, it would fit, but of course I have like a 6-year-old phone, so it would not fit on
Well,
mine. So you've downloaded
they
it.
make a variety of sizes of the model, all the way from one and a half billion all the way up to 671 billion parameters. The one and a half would probably fit on a new phone, but it wouldn't have any room for storage for any other damn thing. In other words, you wouldn't be able to load any other apps or any other damn thing. The uncompressed and what they're calling undistilled FP16 model takes 1.3 terabytes. The model, and I've got all three of those models, the large models, and I've got a buddy of mine that's got all the models, either in a distilled format or non-distilled format.
Can you run that off of a card? If some phones do have, and you can buy a 2 terabyte card.
Yeah, no, you wouldn't be able to run it. There isn't
Too
enough.
slow.
There isn't enough GPU
The
processing
bandwidth.
in there. No, there isn't enough GPU processing in those in phones.
Well, many companies have blocked access to it due to concerns about potential data leaks to the Chinese government.
Oh yeah, they're not safe.
Well, there's
Yeah.
no fucking way. What charging station issue detected? Try a different. My charge just fucking died, and I'm only at 84%. What the fuck?
Well, hang on. Related
Throttle.
to this deep sync.
No, it's not throttling. It turned off the fucking charge.
Yeah.
The
No,
charger
I
is.
understood you. I understood what you were saying, but I was wondering if it was because that was the point where it throttled, and then once that happened, then there was a software issue between the charger and the car.
No, this is EV Connect. They use the ABB charging pedestal, and they're about as flaky as a cornflakes. It's a bowl full of flakiness. I've got that. They're horrible. They're horrible. The Tesla superchargers work perfectly. The chargers at Circle K and holiday stations, they work perfectly. These things are pragmatic. But the reason I charge here is because they only put a $25 hold on my bank account, whereas Circle K puts a $50 hold that doesn't come off for 3 business days. Tesla, they put a $20 hold while the charge is going on, and then as soon as you end the charge, whenever that is, they rebate. They free up that $20 on your credit card again. But the nearest Tesla supercharger is like 27 miles away, so I would have to drive 54 miles to get a charge, and then I'm back to fucking not having a full charge when I get back to St. Cloud to do ride sharing. But getting back to that AI DeepSeek R1 model, what I'm going to end up running that on is a super micro server that has multiple 4090 NVIDIA cards in it. I've got a buddy of mine that is more than willing to let me have some server time. And by the way, I'm on the list to buy the Project Digits desktop PC, which has a Blackwell chip in it, and I'm going to try and run DeepSeek R1 on when it's available in May, and I pay them the $3,000 for it. Um, I'm going to try and run it on that, and that unit is literally about, I don't know, 10 inches square by 3 inches tall.
For those who aren't that familiar, I'm running a very tiny mini computer here. Mini computers are now as powerful as workstations were 2 or 3 years ago. It is
Yeah.
astonishing how much throughput these little guys have. Somehow they've worked out how to get the energy, how to get the heat out of them very, very easily. Many of them don't even have fans anymore. They are able to function with the footprint of a large pack of cigarettes. I've been okay. Let's get Harold in here. He's been very, very polite. Harold, good whatever afternoon.
Hey, is this piece of junk still working or what? Is it?
I'm assuming you. Piece of junk is a good description for the modern world.
Yeah, I just wanted to comment on the GM battery situation. Um, and hey, pup, mute your mic. You're noisy again. The
Say, say again, sir?
mute your mic. You're noisy. Or at least my headphones are good. I can hear you. Thank you. Yeah, there's a new facility, manufacturing facility for batteries opening in 2026 in Canada, and they're going to supply all the batteries for North America. They're doing that in cooperation with POSCO, which is the South, I think it's South Korean manufacturer as well. And that's, you know,
Harold, will those have a tariff on it?
not in
If the
Canada,
tariffs go through, that is.
not in Canada, because there's also the GM engine plant in St. Catharines. They produce the V8, and they also produce a double clutch transmission. Um, my grandfather was the operations manager there. They designed the first, they installed the first radio into a production car. So every time you turn on the radio in the car there, you know who did the job. But yeah,
That's really cool.
my grandfather used to take his cars apart, like he'd get a new car every year, and he'd take it apart on weekends and put it back together. I've got all his tools, and a lot of them are custom designed. I have a tool maker as well. But yeah,
That was probably back in the day when the QEW was a 2-lane highway from like Toronto to St.
yeah,
Catharines too, right?
yeah,
And probably all the way to Windsor.
yeah, back in the day. And yeah, he used to, you know, they had this thing called the Skunk Works, which was GM's research and development for their powertrain. And then they sent the, uh, you know, they had different powertrains and power plants. I mean, today it's really scaled back what they're doing. But that new battery facility in, um, I think it's going to be in Quebec, will be, you know, a major supplier of the next generation of batteries for GM. And also that facility in St. Catharines, they run, I think it's 35% of that manufacturing facility is run on waste gas. So, but I expect a lot of these manufacturing groups to get even more off the grid, maybe with SMR or major solar or even wind. Um, I mean, the wind potential in Lake Ontario is enough to power the majority of Ontario. So
Yeah,
it's going to get more and more competitive.
Yeah,
definitely.
Barra a number of years ago on CNBC made the commitment that GM as an entity was going to be 100% renewable by 2035, and that includes their office space, factories, the whole shot. She's also made the statement on CNBC that by 2030, if you want a fossil fuel fired car, you're going to have to special order it.
Yeah, I mean, there's going to be a whole cottage industry to keep the ICE engines going, and also to convert the ICE engines to hydrogen, and another one would be propane, um, because you're going to lose market. Um, you can the market for gasoline, right? It's going to be very expensive to fill up your vehicle without the mass production. So it's going to
Yep.
accelerate the electrification. And there's a company in New Brunswick here that's and a lot of mining companies in Canada that are building, robotic mining and robotic heavy truck. And you look at those gigantic mining trucks that, could power an entire city, these giant things. The transmissions and are just enormous. Like I worked on some powertrains for Caterpillar, and that how they get the power to those treads takes a lot of gears, and it's a lot of expensive metallurgy versus an electrified vehicle that's just so much easier to maintain. I mean, yeah, you don't need oil changes, you don't need any there's a million times less bearings and bearing surfaces and heat treatment. You know, you have to still replace your tires. You still have to replace your wheel bearings and your brakes, but it's just going to be so
Yeah,
much simpler,
Grandpa,
right?
what's a power takeoff?
It'll take off your arm if you're not careful, or take out an eye.
Hey, Harold, that double clutch transmission, was that the one used in the Ford Focuses?
Oh, this is a GM. I don't know if GM shared anything with Ford. I know that
In the
GM used to
past.
work. Yeah, I'd have to
Well,
take a look. But this is one of the things. I worked on powertrains. I remember I worked on, the powertrain for Jaguar, and that was shared by Lincoln and shared by Ford. And it's just like GM does that too. They create those partnerships with Honda. I mean, it's just, and that's why companies like Tesla are cooked, right? Because GM is coming out with, almost 10 times the manufacturing capacity. So you just can't beat it on price. And everybody has a vested interest in taking, I mean, Tesla's taken itself out.
I,
But yeah,
I, I just wanted to know because I owned a 2012 and traded in a 2012 because the 2012 almost killed me um, due to the transmission. Uh, and I bought a 2014, traded it in on 2014, and I got rid of that fucker because they hadn't fixed a automatically shifted manual transmission that was in the thing.
well,
Um,
do you remember the Saturn transmission?
oh
GM's.
yes.
Well, I was actually employed to make that thing work because, Americans just aren't that talented at this stuff. So I had to go down to America and fix it for them, which I did. And they really thanked me. But yeah, that thing has like a million kilometer, and as soon as that came out, Cummins and what's the other one, Allison, they did not like that transmission because it basically was going to put them out of business. So there was some fishy stuff going on at GM, and this is the problem: is that GM is can certainly create the technology, but the politics and the infighting and the executives that have their heads up their butts, I mean, they really ruined um, GM and Ford. Their leadership, they really ceded the entire leadership of the North American brand with both hybrid and electric vehicles. They should have been where they are now a lot sooner and be essentially dominating the market. There should have never been really a Tesla to ever emerge. You know what I mean? Like they really dropped the ball. And that was
Yep.
because of oil and gas influence within the internal politics, because they knew that, building internal combustion engines is it's too expensive, compared
One of
to,
these years,
yeah.
we're going to have to do a space on this specifically, on how the technology of the automobile industry advanced ad astra per aspera. It really,
Well,
yeah, it was uh,
well,
difficult at best.
there was a battery manufacturer in Ontario, and they had this electric vehicle almost 20 years ago that was designed for city drive only. And it was this tiny little thing, and it would have been a great idea for city workers, police, everybody, and even people buying this, living in Toronto and all this business. And this battery company, they made all the space batteries. They made the 50-year plutonium batteries that go up into space and satellites and stuff. So they had it, and basically the oil and gas industry came in to shut them down. They wouldn't they wouldn't let it on the road because it wasn't safe on highways, and that's how they kept them out of the market. So they, again, when you go up against the big boys, the bean counters will take you out. That you can have the greatest technology. That's what I've learned in design, is that the greatest threat to Earth isn't the science, it's the dummies stopping it from from happening. Anyways, I'll leave
I
it at that.
Okay.
I
Humans are the biggest asteroid.
I can tell you, when okay, so I own a Duramax 3/4 ton, and was looking to convert the transmission in my motorhome to an Allison 1000, and I did a deep dive on it. If you buy an Allison and you use the GM TCM, you'll get about 300,000 miles between rebuilds. If you run the same transmission with an Allison TCM, you'll get 1.2 million miles between rebuilds. And it's because Allison knows how to make the thing shift gears without burning up all the bands and clutches. And GM evidently, at least in '05, did know how to do that.
Yeah, I worked on that
Well,
that transmission casing for the Allison, and I did the inner bore precision diamond boring, and each one of those tools, there was 8 of them. Each one of them were $250,000 each. And it's like a drill bit with diamonds,
Yep.
that's high speed machining. And they used to take off at each step of this process. I took off zero point 0.3 millimeters of material at a time, and that
Wow.
was that was a cycle time of uh, 12 seconds. So we produced a finished powertrain every 12 seconds,
Wow.
a fully
I,
assembled and fully tested every yeah. That was a
the,
big
the
operation.
other thing that
I want to. Oh,
the other thing
I
I had a
wanted
heartache with was, real quickly, and then I'll shut up. But the other thing I had a real fucking heartache with is in a stock Allison, GM Allison, they ran the fifth gear, which was their top gear. They modulated the pressure down to 80 psi, and if you're making more than 400 horsepower, it fucking slips, then goes into fucking limp mode, growl. You know, all the little mods to it will run the fifth gear, when you got your foot in it. They'll run fifth gear pressures right up at line pressure, 150 psi, and it grabs and holds. Allison 1000s are fucking bulletproof. Anyway,
okay. Marie Louise, welcome to the space.
Hello. I saw the title and I saw some Democrats because, listen, I'm not going to get into it. I'm a little depressed right now, but it's okay. I wanted to ask about the title because it says something about crypto. And my head is going a different place. I guess the guys were talking, and not to get into that discussion, but
We
mining,
drift.
my, say that again, I'm sorry.
We tend to drift.
Wonderful, wonderful. I love it. I do too. It's the best conversations, not to be rigid, but but anyway, crypto and the United States dollar. Couple of things I've heard is that Biden made the dollar strong, but that Trump and them are coming in and bringing crypto, XRP, Bitcoin, and now Mr. Musk is bringing in Dodge. Let me just ask quickly: are we? Is there going to be an overtake of the financial systems? Everything is digitized. I understand all that. I don't want to get into. I'm thinking of the big picture. Do you think that crypto is, I don't want to use the word hostile takeover, but do you think that crypto is going to take over? It could.
Um,
There's so many. I'll shut up. Just you see where I'm going. I.
my my personal my personal opinion is the United States, that the U.S. dollar is the world's currency. So if we were to change that, it would explode inflation, and it would also make the United States consumer so much weaker. We gain such a benefit how everything pretty much globally is in dollars. If you want to buy a barrel of oil, it's in dollars. If you want to buy any commodity, cocoa, chocolate, if you want to buy orange juice on the world market, it's almost always in dollars. So if we were to go away from dollars, it would hurt every American business so badly because we would now be floating instead of stable. So I
Abs-
cannot imagine we would do that.
Can I can
Absolutely.
I
And
can
again,
I
listen. Trump is buying.
Please, okay.
Am I right? Trump is buying XRP and Bitcoin. Is he? Did he do the deal? Yes or no, and go from there because this is what's happening.
okay, so everything that Sal said is 100%. And the reason I believe, I'm going to take ownership for this, that they are trying to destroy the American dollar, USD, is because there's a lot more room for graft and grift and corruption in cryptocurrencies.
Yes, sir.
And
Yes, sir. Yes, sir. I'll shut up. Yes, sir.
you can't
Yeah,
steal money, but in crypto, because the blockchain is encrypted, and we really don't know, who's holding what, where, when, and how. A good example of them trying to force the move into crypto is, I guess it was a week, 10 days ago, the U.S. Marshals were about to auction off several $billion worth of cryptocurrencies that they had picked up, when they bust a bad guy, right? And Trump put the kibosh on that. Um,
Trump
Dogecoin,
stopped it. Trump stopped it and confiscated it. What did Trump do? He stopped it. He
he stopped the auction because he
okay.
wants to create a reserve, a U.S. government
yes,
reserve cryptocurrency, cryptocurrency reserve, and
and a sovereign fund.
he's going to take all that cryptocurrencies and dump it into that reserve, which then puts those billions of dollars under his fingertips, and he can fuck with it in any way he wants to,
Yes, sir.
i.e., pay himself.
Yes, sir. Yes, sir. That's what I mean by the takeover, sir. That's where my head was going. You see, my head is different than everybody else's, but now you have something to grab onto. We all
And
do. Yeah.
and by the way, his two little crypto coins,
Rip-off.
tokens.
The rip-offs. Yes, sir.
Oh
The rip-offs.
God, rip off. That's an understatement. But anyway, they're based off the Ethereum blockchain. There was a big
I,
argument as to whether they were going to base it off the Solana blockchain or the Ethereum blockchain. And the Solana guys were trying to push it in that direction, but you really couldn't do those kinds of contracts, because that's really what it is.
Yes, yes,
On
yes. And her collectible Mimi coin, Mrs. Trump, hot lady nude model. Let me shut up.
Yeah, well, and if you look at the name of the coin, it's got a dollar sign in front of it and then her name. So if you sound it out, it's Smellania. It smells all right,
I see
I,
this. Wow, let me shut up. I'm going to go. Thanks, guys. Good morning.
but it's a
glad to
really
have you on
bad
board.
idea. A really bad idea to eliminate or destroy the U.S. dollar as the reserve currency of the world. And Sal, you're right on the money there.
Did Trump buy the XRP yet in the Bitcoin, or is it just a proposal? Did they buy it all? They confiscated some, right? It's there. But did they
It, it
buy any also, or let me shut up?
there's no way of telling, because you never know who's holding it.
Right.
That's true. That's why, again, I'm just going to amplify what I said earlier. We are uh, the envy of the world, which is why the BRICS are trying so hard to create their own currency as a reserve. It's so easy. You travel anywhere on this planet, you wave a dollar bill, you're good, because nobody's going to complain. You're going to get the best exchange rates. The United States dollar is the world's currency. And if you're going to mess with that, we're only 4.5% of the people on this planet, but we're about 30% of the global economy. So you're going to tank the U.S. economy if you do that. It's not going to be the end of the world, but yeah, it's the dollar. If you shrink the value of the dollar, it is going to hurt every single American, except for maybe those people who are in currency speculations who are only doing things in Bitcoin. So it doesn't make sense, and that's why I think he may want to do it, and some of his people may want to do it. But the absolute certainty is nobody else will.
Yeah,
It's
he
a
wants to burn our economy to the ground.
well,
He and Elon.
it's a takeover, and it's them. It's listen, he's conquering lands. They're thinking already, what is it? Iceland, Greenland, Gaza, what else? I'm just going,
Panama.
whoa, I better go to work and work on my own stuff. But man, I mean, this is pretty shocking. I'm going to shut up. I mean, I'm not that shocked, but again, I'm a little astounded. I really am, and I love the dollar, so I love America. I'm going to shut up, you guys. Thanks for, but you see where I'm going and what I think and what. Wow, it is an economy takeover. Let
Well,
me.
let's put it this way. About a month ago, um, I liquidated all my individual equities into cash, and I, other than two index funds that mimic the S&P and the Dow, DJIA, I am equities. I'm cash heavy and equities light.
Well, they all seem to want to go with it. BlackRock and them are doing the stock exchange in Texas, which is going into securitized mortgages, which I don't know how Elon and them, if they'll want to protect that or not protect. God, oh my God, oh my God, oh my God. Let me shut up. I don't want to have them banging at my door. Let me shut up.
I want to put in a brief point in something that came up, I don't know, about 15 minutes ago. Uh, Tesla is doing the best job since Jaguar, at self-destroying their own brand.
Yep.
So remember that Musk's wealth is is on stock that he hasn't sold. And as Tesla continues to plunge, And because he is the principal shareholder, he can't just say, I'm going to sell 1 million shares overnight. He's got to do that as an announcement, and that will completely eviscerate. So anytime he wants to capitalize his ownership, it costs him a fortune because the stock falls. So he's the world's richest man, but he's only the world's richest man as long as Tesla is worth something. If
I
he
think
tanks Tesla, he's not the world's richest man by even close anymore.
I I think Trump's going to want to give him money because of his listen.
Oh,
I'm
he's gonna try, yeah.
Yeah, he's just doing what they want. They're doing exactly they're just I'm watching this and I'm going, "Whoa, this is like cowboys and Indians here. They're going into the office and you're not coming in and banging up the doors and oh, I this is yeah.
See, I don't think
But the
Trump is
real
going to.
the
I
real
don't think
world still exists.
I don't think Trump is going to give him money. I think Trump is going to allow him to steal money.
Yep, that makes sense too. That makes sense too. I Again, he'll get all the contracts, all the subsidies that way. God, I'm almost afraid to say too much, but yeah, because you got to word it in such a way you don't want to come off. You want to word it in a legal way that how can we? Because I mean, you got to find the right spin, but yeah, I don't want crypto. God, I don't know. I mean, I'm not in control, but I see things. So, but yeah, Tesla, those batteries are really dangerous, and when they catch fire, that is beyond a hazardous waste. So those
It
batteries.
depends. It
Go ahead.
depends on the chemistry of the battery. And as we were talking earlier, the iron phosphate ultium batteries are much safer. The cattle is CATL. Cattle's batteries are much safer. We are going to a world where the electric car battery is becoming, in every way, safer, lasting longer, more charge rate, more charge cycles. This technology is superior dramatically than anything else that we've ever had in the automobile industry.
Yeah, regarding Tesla, when I started my adventure on buying an EV, I test drove everything I could get my mitts and scrabbins on. I rented a Tesla for 2 weeks. I could go on a 1 hour diatribe on why I didn't buy a Tesla, and I'm sitting in a GM. They are they are in so many ways, shapes, and forms horrible. Anyway,
Sorry about the noise,
I'll,
Maggie. I've always I'm unboxing something. That's why I've always heard from people who are really in the know. I've never driven a Tesla. That they are the cars for people who hate driving cars. Which is why
they're a car that
FSD is
if
so.
you they're a car that if you have a lot of money and you want to be cool, you buy a Tesla. Um, they, uh, 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 their their software is flawed. This comes from somebody who writes and has written a lot of AI based code. Their AI is just adds so many bugs in it. In the 2 weeks that I owned it, it did 3 software updates, over the air software updates, trying to patch shit, and it still didn't work right. Um, their diagnostics is a proprietary cable that has to be connected to an internet connected laptop, and for a paltry $160 a day you can use their software to diagnose your Tesla. The problem is that their software doesn't do real-time diagnostics, so if you have an intermittent problem, you're screwed, blued, and tattooed. You're fucked. um
If, they,
I,
if so, it's, Yeah, I'm trying to work that out. So if it's not real time and the fault is real time, and then the fault goes away from an overheat issue or anything like that, thermal shutdown, how the hell are they going to figure it out?
a loose wire will drive it fucking crazy. a bad connection on one of these fucking connectors that's got 50 some fucking pins on it. If one of those connectors gets a little bit of corrosion in there, and it's a, you know, it's a resistive sensor, now it's sensing wrong, and it'll throw an error code. But then by the time you get the whole fucking thing plugged in and you wiggle the connector, it's okay again. But like, which pin is it, motherfucker? You know, it just, I'm blowing down the highway on Highway 10. It's a 65-mile-an-hour zone, and on the screen, it sees the speed limit signs, right? If it's 65 miles an hour, what you see on screen is a post sticking up out of the ground with no sign on the top of it. But it correctly identifies 55, 60, and 70. Uh,
I have
the,
seen with other cars, yeah, that the speed limits detection system that's based on visual detection can sometimes screw up. It's not just Tesla.
yeah,
So,
no. On a rainy day, so it's got two cameras in the door pillars. And as soon as you get one drop of water on it, it throws an error message that says, I can't see that camera. Take me in and fix me. And you reset the, you know, you clear the message on the screen, and 30 seconds later it comes back. I can't see the
uh,
camera. Oh, I can't see the other camera. And I spent coming home from fucking St. Cloud. I spent literally 2 hours doing nothing but hitting that fucking clear button on the goddamn screen. There's no way to turn that off.
oh, just general order, 10-minute warning because I have to go. And I wanted to also mention next week, we still haven't gotten the main topic, but we are looking as an auxiliary topic, songs about the ecology, but they have to be positive songs. So, not negative songs about the ecology. Essentially, this is our Valentine's Day special. So, bring us your songs that you've heard, that you love, that you appreciate, that deal with the positives of the love of nature, the love of the physical world. Well, be careful about that. That can be troublesome. Uh, okay, so like I said, 10-minute warning, guys.
Hey, I got to go to work. You guys be safe, man. Thanks for having a space, Sal.
My pleasure as always. Uh, because actually, I also I have to pick up my wife from work, but I'm also getting a I need help message from my sister-in-law, which is why we're holding it. We're going to do it to 10. Sometimes we do extend, and I simply leave it to go while I'm driving. But today I'm navigating through a snow and slush field, so I don't feel like having that in the background while I'm trying to avoid getting killed. Are there any questions? Are there any comments anyone wants to make?
Well, I'll just trace it back to what Pup's last comment was about his computer system in the Tesla, is that it all comes back to AI, uh, maybe the inadequacies of AI, and where we're at. And I hope we can discuss AI a little bit more next week.
Yeah, this was just power, but yeah, we can go beyond that because I just wanted to talk about
Okay.
the today we were just talking about the power drain that we never didn't even get a chance to talk about streaming, and I never got to talk about transistors and all that stuff. But
I
Oliver,
know.
Hi, hi. I wanted to. It was you were talking about what's his name, Elon, and his grasping necessity to grasp power. I've read a little about his ambitions, and it's clearly that what he's after is space contracts. Basically, he'll do anything for government space contracts with presumably NASA, and he's doing it up against Bezos. And one of the reasons all those oligarchs were up in a line, they're all kind of fantasizing about this space. I won't call it nonsense because it's not nonsense. It's clearly a thing. But he's just after, you know, as much money or as much contracts as he can get from
What scares
presumably the government. It's not
what
my
scares
idea. It's, I mean, a lot of people talking about
no
it.
what,
Robert
what scares the
Wright's very
living
good on it.
what scares the living daylights of anything having to do with space is as we keep on throwing more satellites up there, there is the greater risk. It's a combination of natural disaster risks, of technological disaster risks, and sabotage risks. And as we keep on, putting more and more, I hope that somebody decides to keep on going with the fiber optics and lower cost, higher bandwidth systems,
Yeah.
terrestrial systems, not just everything being satellite based. I admit, there are advantages to satellites, obviously, but there's disadvantages. And the main disadvantage of the satellites is bandwidth and cost. And it's still much, much cheaper. We were talking very, very briefly last week about photonics. Photonics is instead of turning uh, transistors on and off by using electricity, turning them on and off using light, and then transmitting that light as the signal. The main barrier toward getting computers to go faster right now is the physical speed of light inside of an electric circuit. The speed of light in an electric circuit isn't exactly the speed of light. It's roughly like 0.1 C, but there's also the latency speeds and the latency energies required. This is why I was telling you about, transistors. So
Hey,
going into
Saul,
photonics would, yes.
did you hear about the announcement from Canada?
Uh, what's it about?
Uh, it was a few days ago. Canada announced the first scalable photonic quantum computer. You know, we
I
built
haven't
the
heard it.
quantum computer for you guys because you guys aren't good at computers, right? Yeah, so we've got an optical quantum system, and we won't be sharing it with you until you guys do something about that guy, and then we'll talk.
This is at the start, the first 10 minutes of this show. I was talking about the problems with supply chains and the problems with having so many sword of Damocles over everybody's head because nobody wants to have a contract that doubles overnight. You're buying something, a proprietary part for X number of dollars, and you don't want to, all of a sudden tomorrow that same price is going to cost you $1.25 or $1.50 or $2 because that just completely kills your business model. Businessmen like, I shouldn't say this. Everybody likes consistency. Everybody likes predictability.
Routine.
Nobody likes having something all of a sudden in the middle of nowhere having a dramatic increase in price or costs. Everybody wants predictability, stability, and Trump is the opposite of this. He
Oh,
prefers
oh,
dynamic noise.
should I also add that the majority of IBM's AI campus is in Canada, not in America, because again, it's so hard to find, you know, informed Americans such as yourself. Um, you know, you're a rare
IBM
find in
used
America.
to IBM used to run this part of the world. I am in Lower Westchester. The Armonk main facility was about, I don't know, like 12 miles away from here. The Tarrytown facilities, oh my God, the Kingston facilities, they ran up and down the Hudson River.